Hi grade 11s and welcome to this video. In this video, we are going to be working on the grade 11 maths paper 2 from the November 2023, and this is KwaZulu-Natal's paper. Okay, so in this paper, as you can see, this was written not long ago. We have a total of 11 questions, and here are the mark allocations for each question. So a nice thing, this is actually really nice to have, because many a times people spend a lot of time on the question that doesn't really require that much work, okay? So it's a good way for you to just manage your time. Okay, so we have the instructions. Just remember that you need to answer all the questions, show all your calculations, and round off to 2 decimal places when necessary. The diagrams are not necessarily drawn to scale. So if something looks like 30 degrees, it doesn't mean that it's 30 degrees. You would have to first prove and find out what the size of that angle is, okay? Not assume angles based on how they look. Okay, so this is what we have. Question 1, and this is the scenario we have. Okay, so question 1 says, Apelele plays for his school's cricket team. The number of runs scored by Apelele in each of the 8 games that he batted in is shown below. Apelele was given out in all the games. Okay, so he's playing for his school cricket team. And they also tell us that the number of runs that he scored is given. So in the 8 games, so there are 8 runs here. And he was given out in all the games. So given out, it probably just means that, he maybe didn't qualify. Okay, so given out, it doesn't sound like a good thing. But these are all his scores. So 1.1 says, determine the average number of runs per game scored by Apelele for these 8 games. So they just want the average. Okay, the average, another word for average is mean. When they ask you for the average, they're really asking you for the mean, and this is the symbol for the mean. So let's calculate the mean of this. It is for 2 marks. It's very important to look at that mark allocation. It's for 2 marks, so you actually have to add all the numbers up. It's going to be the sum of all your data points, all the values that you have there, and then you're going to divide by the number of data points, by the number of values we have. Okay, so what I'm going to do is I'm going to add all of these up on the calculator. Be very careful. Then I'm going to see what that adds up to first before dividing. Okay, when I add everything up, this is what I get. I get 128. So I'm going to say 128, and I'm going to divide by the number of values that we have, which is 8. We know these are 8 games, and you can even count them. You'll see that they are 8. So divided by 8. So the mean is going to be all of that. So I'm going to just say it's equal to, and I'll just say divided by 8. And then it gives us 16. So 16. You can put it as 128 over 8. That's also fine. So there we go. That's the first question done. Moving on to the next question. The next question says, determine the standard deviation for this data set. Okay, so we just have to find the standard deviation. And this is for 1 mark. So you have to use the calculator to determine the standard deviation. Okay, so this is how we're going to do this. Now, this calculator works a little different to how the normal Casio calculator works. So what I'm going to do is I'm going to input some sort of video recording on this side of that calculator, and you'll just be able to see it as normally. Okay, so in order to input this on the calculator, what we're going to first do is on your calculator, you're going to have to press the button mode. And then mine is a little different. You see, I have more options because this calculator is a bit different. But you're just going to have to go to the option that has stat. Yours is probably going to be number 2. So mine is number 3. I'm going to go for number 3. And then we're going to go for option number 1 that says 1 VAR because we have a 1 variable type of data. Then you're going to have this, and yours is probably going to look exactly like mine here. And what you're going to do now is fill in all your data points, all your values. It's going to be 8 in total. So that is 21, and we're going to have 8, and then that's 19, and then 12. Okay, so, and then I also just make sure I check that I do end at 8. When I see that I end at 8, then I know, okay, these are actually all the values because I know there were 8 values After doing that, you're going to press AC, Shift, and the button number 1. Okay, now you have some options that you have here. You're going to go to the option that says VAR. Okay, so we're going to go for number 4, and then we want standard deviation. So you see this one here with the standard deviation looking symbol. This is the standard deviation symbol, right? You're going to take that one. Do not take anything that has an n-1. Okay, that's not. So you're going to go for that one. Mine is written like this, standard deviation of x values, and that's option 3 for me. And then I'm going to press is equal to, and this is what I get. I get 7.55 rounded off to 2 decimal places, and that's my standard deviation. Okay, so that is 1.2 done. Moving on to the next question. 1.3 says, Apelele wants to be selected for the district trials. The condition is that he needs to have at least one score above 2 standard deviations from the mean. I need to be highlighting these things. So he wants to get, accepted for the district trials. He wants to be selected for that. But the condition is that he has to have at least one score, right, that is above 2 standard deviations from the mean during the first 8 games. Will he be selected for the district trials? Motivate your answer with the relevant calculations. So we need to find out if he's actually going to be selected for the district trials. And the condition is that we need to check Apelele's scores and see, does he have one score at least, okay? Meaning at lowest, the lowest amount of scores he must have is 1. Does he have at least one score that is above 2 standard deviations from the mean? Well, in order for us to be able to answer this question, we first have to know what exactly 2 standard deviations from the mean would look like. Okay, so this is all this is talking about. You have the mean, right? And we're looking at 2 standard deviations from the mean. And so we need to look for scores that are going to be above 2 standard deviations, okay, from the mean. So if you have the mean, we're going to look at 2 standard deviations. Look, if we move 1 standard deviation, right, away from the mean, that interval right there is going to be mean plus your standard deviation. But we need to move 2 standard deviations away from the mean. So that's going to be at mean plus 2 standard deviations because we're moving an extra standard deviation. Okay. So they're really just asking us to find the values that are greater than this number. Because his scores, we have to find out the scores that he has that are above 2 standard deviations. So they need to be above this number. So in other words, they need to be greater than whatever this number is going to give us. So we really just have to find out what exactly the mean plus 2 standard deviations is going to give us. Okay, so let's go ahead and find out exactly what that is going to give us. Well, we know that the mean is 16. We already found that in the beginning. So that's 16 plus 2 standard deviations. Well, 1 standard deviation is 7.55. So 2 standard deviations, you would just multiply that by 2. It's 2 of those standard deviations. So I'll say 2 times 7.55. Okay, and then let me just do the calculation. Now you can calculate normally on your calculator even though it's in this setting. You can just press AC to remove the data that you have. So all I'm going to do is I'm just going to press AC and I'm going to do the calculation. Even if I didn't press AC, it will still work. So 16, and then I'm saying plus 2 bracket, the standard deviation is 7.55, and then close that and let's see what we get. So we get 31.1. Okay, so that is 2 standard deviations above the mean that we have. Now that we have this number, what are we going to do with this? Well, the thing is, they want you to find at least one score that is above 2 standard deviations from the mean. So now that is 2 standard deviations from the mean, specifically 2 standard deviations above the mean. We are looking for numbers that are going to be above this. Okay, in other words, numbers that are greater than this. He has to have scores that are greater than this number for him to be selected for this district trials. So let's look in the numbers above. It's 31.1. does he have any number that is greater? Does he have any score that is greater than this? Well, if you look through, you see that 32 is greater than this. So he has one score that is above it. So that would mean, yes, since he has 32, he would qualify. He would make it to the district trial. So you can just answer them in words. Okay, and I just answered, yes, he will be selected because he has a score of 32 that is above 2 standard deviations from the mean. Okay, so he has one score that is above 2 standard deviations from the mean. Okay, and that is 1.3. And moving on to the next question. Okay, so 1.4, we have Apelele hopes to achieve an average of 20 runs per game for his first 13 games. So on average in total, he wants to get 20 runs for the 13 games. Okay, what should his average number of runs per game be for the last 5 of these games in order for him to reach his goal? Okay, so let's look at this. Let's break this down. Focus on as well on what they asked for. So he hopes to achieve an average of 20. Remember, it's already an average. It's already a mean. We've already taken the sum of all the runs and we've divided by the number of runs. Okay, that's what we've done here already, by the number of runs. And they gave us 20. And they're telling us that this is for the first 13 games. So we even know the number of runs is a total of 13 games, right? But what we're trying to find out is what should his average number of runs, let me even highlight that in yellow. What should his average number of runs per game be for the last 5 of these games, okay, in order for him to reach his goal? So we need to find the average number of runs for the last 5 of these games. So if you're trying to find the average of the last 5 games, you'd have to find the sum of the last 5 games and divide it by the number of games, which is 5. The last 5 games has 5 games. Okay, so that's how we're going to find this. So from this, I can see that in order to get what they're asking for, the average number of runs per game for the last 5 games, I need to first find out what exactly would be the sum of his scores for the last 5 games. Okay, so let's see what we have now and how we can actually find this. So I need to find the sum of that. Well, first of all, they told us the average already that he wants to achieve. And he's going to achieve this average of 20 runs per game, okay, within 13 games. So if we want to find the sum of that, because in order to find the sum of the last 5 games, they may even break this one up further. To find the sum of the last 5 games, remember, how many games has he played so far? He's played 8 games so far. We would have to find the sum of the 8 games, right? And if we can take the sum of the full 13 games, if you take the, let me even just be using the sigma for sum, okay? The sum of the full 13 games, if we take that and we subtract it by the sum of the 8 games, we're going to end up with the sum of the last 5 games. So that's my plan here. I want to get the sum of his 13 games and subtract it by the sum of the total 8 games. Now, there's one that I have here. I actually have the sum of the 8 games. We found that already. That was the average before. You see, he played 8 games before, and that was the average that we had, 16. So it means that the sum of his scores for the 8 games was just 128. We have that already. So here, if I substitute minus 128, the only thing I need to calculate here is this part. What exactly is going to be the sum of his 13 games? Well, this can help us find it. If we know that the sum of the runs, okay, within the 13 games divided by 13 gives us 20, then we can actually find this. It's like looking at this as x and you're trying to solve for x. How would you solve for x? By getting rid of the 13. Well, the 13 is dividing, okay? It's been divided into that. So in order to get rid of something that is dividing, you would multiply. But because this is an equation, what you do on the one side, you must do on the other side. So we just multiply both sides by 13. 13 would cancel here. This would give us the sum of the runs. Of course, this is of the 13 runs. Okay. And then this will be equal to 20 times 13. 20 times 13 gives us 20 multiplied by 13. That is 260. So 260. That is the total number of runs for the 13 games. Okay. That's what we're going to put here. So if we say 260 minus 128, we will finally find out what exactly the sum of the last 5 games are. So 260 minus 128, if you say that minus 128, we get 132. So he should have at least a sum of 132 runs in his last 5 games. But focus on the goal. What they want you to do is to find the average number of runs per game, okay, that he must have within the last 5 games. So what we need to do there is find the average of this. This is the runs for the last 5 days. So to find the average of that, it's going to be the sum of the last 5 games, which is 132, divided by 5, because it's only 5 games that are here. And then that would give us, let's go ahead and see what that gives us. 26.4. That's what his average must be. His average for the last 5 games must be 26.4 in order for him to actually achieve this goal of 20 runs per game for the total 13 games. Okay, so now moving on to the next question, 1.5. Okay, so 1.5 says, Brian plays in the same team as Apelele, and then we have, after having played a few matches, he has an average batting score of 37 runs per game. Okay, so this is Brian. Brian has a batting score of 37 runs per game. That's quite higher than Apelele's score, but okay. Then they say the standard deviation of his scores is 13. Standard deviation of 13. In the next 2 matches he played, he scores respectively 20 runs and 0 runs. So he scores 20 and 0. Will the inclusion of these 2 scores cause the standard deviation of his scores to increase or decrease? Justify your answer. Okay, so finding out whether the standard deviation is going to increase or decrease. With standard deviation, what you really have to focus on is standard deviation. What standard deviation is, it tells you the standard, should I say, variation in your data. They're trying to see, standard deviation helps to measure how spread out your data is. And so it's very different from the mean. The mean just measures the average, right? The mean of data really just measures kind of like the center value of all your values. It will look at all the values and like, okay, roughly this person keeps getting around this number. So mean is a measure of central tendency. It measures really what the values are roundabout centered towards. Okay, how much they are roundabout centered towards. Standard deviation, on the other hand, measures something completely different. It measures how spread out your data is. Okay, but it has a lot to do with mean. It really just gives you, it's like an average as well. It is an average. It measures the average difference really between each data point and the mean. Really, okay? So this is really what it's doing in as a visual representation. You see, you have your mean, which is like the central value, roundabout what every other number is roughly leaning towards, right? So what the standard deviation is going to help you to measure is this. You see, you have one data point over here, and then you have the mean. It's checking how far exactly is this data point from the mean, okay? Then that could be like, maybe it's just 5 units away. Like, okay. And then we're looking at another data point. How far is that from the mean? It's maybe 2 units away. And then how far is this from the mean? It's maybe like 1 unit away. And then we check this one, maybe it's about 4. And then maybe this one is about 7. Maybe this one is about 9, right? These are all how far these data points are going to be from the mean. You can say data points or data points. I know sometimes I say data points, but it's really the same thing. So if we're looking at that now and seeing how far these values are from the mean, this is what the standard deviation measures. It measures on average how far each data point is going to be from the mean. So it's kind of going to take all of these values and kind of sum it up and divide it by the amount of values that you have. You see, it's like the average of the differences between each data point and your standard deviation. Okay, now the way I explained it on a very basic level. That's not usually how it's even calculated. How it's calculated is that you usually look at it like this. You take your data point, which I'll just call x, the first x value, and you minus it by the mean. Then you square that. Then you take your second point, minus it by the mean, then you square that. And then you take the third point, minus by the mean, and you square that. And you keep doing this to each data point. Then we sum up all of them. We add every single thing, right? And then we divide by the number of data points that we had. For example, if it was 7, we'll divide by 7, right? Then we take that number. That number is what we call our variance. Okay, this is not how we calculate it. This is just a quick revision, just so that you understand exactly what standard deviation is, because it's going to really tie into what happens when you add these scores. Okay, so that is what we call variance. Then if you want to get the standard deviation, you have to square root this value. Okay, if you square root the variance, you end up with your standard deviation. And that's why this is the symbol for standard deviation, because this is the symbol for variance. Okay, so the whole thing I just really want you to focus more on is this whole idea of the standard deviation measuring the average differences between each data point and the mean. I want you to really look at this carefully, okay? And let's look at the type of data points that was added here. So if you had the mean and you had your data points and you have your standard deviation, and now we look at this that is being added. Look at the scores that are being added, 20 and 0. Okay, let's look at 20 first. 20 is added. What does this do to the standard deviation? Well, we're going to look at 20 and you need to compare it to the mean, because the mean is the central value. You notice that if you add a point that is closer to the central value, like if you add a point that, since this is like 37, right, that's our mean. If you add a point that was like 30, not really that far, it's not going to affect the standard deviation that much in this case, because you're adding a value that is quite close to the mean. It's not really that far from the mean, right? And so the difference or the distance between your point and your mean is not that far. It's not that big. The problem happens when you add a data point that is quite far from the mean, okay? Because now if I add a data point, and this is a good example, 20, okay, 20 is far from 37. It's like 17 whole units far from 27. You see now that the distance between that data point and the mean has now been stretched. This will affect your standard deviation. Your standard deviation measures on average what the distance between each data point and the mean is. Adding a value that is far from the mean is going to make the standard deviation bigger, because it's making the distance between the mean and that data point further. Those 2 points are too far from each other. And so it's going to make that distance bigger, therefore making your standard deviation bigger. So you see what that did with 20. And then they still added the score 0. That is way far from 37. 0 is like 0, right? And look at that distance now. See how far that is? Because standard deviation is measuring the average distance, really the difference between your standard deviation, between your mean, and your data point. What it's doing is this distance is quite big now. And because of that, this is measuring the average distance. It has now increased. It will increase because of that. So generally what that standard deviation is going to do is that it's going to increase, because you're now putting points that are far from the mean. You are widening that distance between the mean and the data points that you have. Okay, so now because of that, what it's doing is the standard deviation is now going to have more variation, meaning your values may not be as close to the mean as they were initially. So in as a sum, I just want you to realize that when you have a standard deviation that is low, right, you're generally going to find your data points would be values that are close to the mean. They're not that far from the mean. Like you have 37, okay, you have like 30, 31, maybe 32, maybe even 42, something like that. They're not going to be that far from the mean. But if your standard deviation is high, you're going to have values or data points that are far from the mean, because in this case, the distance between the mean and your data points are now bigger. Okay. So that's really what happens. So you're always going to have to, in this type of question, you're going to have to look at the points that they added and their relationship with the mean. So in this case, I'm going to say that the standard deviation is going to increase. Okay, why is it increasing? Because you're adding values that are much far from the mean. I shouldn't say greater than the mean. It's not about it being greater. It's the fact that they are far from the mean. They're not values that are close to the mean. Okay, so I just said the standard deviation will increase because 20 and 0 are values that are now close to the mean. And so this will increase the standard deviation and cause more variation in the data set. Okay, so moving on to the next question now. Question 2, we have group data. Okay, the first question or the scenario says the table below shows the height in centimeters of 250 grade 11 learners. So these are their heights. These are people who have a height that is greater than 145, but less than or equal to 150 centimeters, greater than 150, but less than or equal to 155, and so on. And then we have the number of learners. Okay, so we see we have 6 learners that have a height of 145 all the way to 150. And that keeps on going. Then they have a cumulative frequency column. Okay, remember, this is just an accumulation of the frequencies, adding them up. The first question, 2.1, wants us to calculate the values of A and B. Okay, so you have to use the cumulative frequency. You have to remember how the cumulative frequency is added up. And it works like this. You see, the first number, you just drag it over to the right-hand side. Okay, and the reason why is because you only have 6 here. So it's 6 plus nothing is 6. Okay, then to get the next number, you say 6 plus the next frequency, and that will give you that number. You see? So, you see how I just said that? I said you say 6 plus the next number to get this number. In other words, I'm really just saying 6 plus A would give you this number of 29. And so like this, you can calculate the value of A. A is just going to be equal to 29 minus 6. So 29 minus 6, that is 23. So 23. Okay, so I'll fill that in because I know what A is now. That is 23. Okay. Now to get B, how you do that is you don't have to keep adding, but yes, it does add up like that. It is 29 plus 60 will give you 89. 89 plus 74 would give you B. Okay, see, 89 plus 74 will give you B. You just have to keep adding it like that. You drag the first one. This plus this would give you this. And this plus this would give you this. And this plus this would give you this. So for B, I'm just going to say the 89 plus the 74 is what is going to give me B. Okay, and so by that, B is going to be equal to, let me just check that. So what is 89 plus 74? It's 163. And there we go. So there's the value of A and B, and that's how the cumulative frequency is going to work. The next question is calculate the estimated mean height of the learners. Okay, I am glad this question showed up because in grade 12, it doesn't really show up much. Okay, shows up once in a while. How to calculate the estimated mean? This is how we're going to do this. You see, it's estimated because this data that we have, these learners' heights that are being measured, we're not finding each learner and asking, what's your height? And the person's like, oh, I'm 148. And the next person, what's your height? I'm 149. We're not doing that. What they did is they asked all those questions, but they decided to group them in classes. So everybody who falls within 145 to 150, they put them in one class. And there are 6 learners that fall here. So to calculate the estimated mean, what we're going to do first of all is we need to first find an average of this height. Okay? A midpoint of this height. And we find the midpoint by saying 145 plus 150, and you divide by 2. Why are we doing this? Because we're not going to go to each learner and start asking them, what's your height and what's your height? We're not going to do that. So what we're going to do is find an average of each class's height. That's why we're saying 145 and 150 divided by 2. And that number, we're going to pretend is going to be the height of everybody within this class. We're going to pretend that we're going to use that number as the height of everybody in this class. There's 6 people here. Okay, so what's 145 plus 150 divided by 2? And when I do that, I get 147.5. So 147.5 is what I'm going to use as the height for the 6 learners in this category. Okay, we take an average height, we're going to use it for everybody there. And we're going to do the same thing here. We're going to say 150 plus 155 and divide by 2 to get an average height of everybody that is here. Okay, so again, 150 divided by 155. I'm just going to add a 155 there. It's the same thing really. Okay, 155 plus 150, 150 plus 155, same thing. And we get 152.5. Okay, so you get the drill now. We're just going to keep adding these 2 numbers, divide them by 2. So I'm going to do that and put it all down here. Okay, so I've written down all these numbers. And what we're going to do now is we are going to we don't just put these numbers and then find the sum yet. Not yet, okay? When you have all these numbers, let me just get rid of that highlight quickly. Okay, so when we get all of these numbers, this is just the midpoint that we got. We got the midpoint of each of the heights, okay? Now, in order to get each person, because it's still a mean, I know it's estimated, and it's really only estimated because of the fact that we are just finding a rough estimation of everybody in this class as 147.5. They're not all 147.5. We're just grouping it as that because we didn't meet all these learners and ask them individually what their height was. But now the thing is, I can't just take this number and use it like that. Okay? This is the height of everybody within this class. But how many people were here? There were 6 learners here. So I have to take this height and multiply it by 6 because there were 6 people with this height. Okay, that's where we say the midpoint multiplied by your frequency. Okay, so that is the 147.5 multiplied by 6. And then in this class, we're taking a rough estimation on average of 152.5 as everybody in this class. But how many people were in this class? It's 23 people. So I'll say times 23. Now just get all the answers. So you see, it's the midpoint multiplied by the frequency. Do not multiply by the cumulative frequency. That's different. You need to multiply by the amount of learners in that class. Okay, so I'm just going to do that as well and then find the answers as well. Okay, so that's multiplying everything. And then I'm just going to find what they are equal to individually. Okay, so these are all the values. Okay, so these are the values that we're now using as if they are our x values. We're using all of these as our normal numbers that we have. And we have to find the estimated mean. So to find that estimated mean, okay, of course it's estimated, you're going to take the sum of all of these. So that midpoint times the frequency. You're going to take the sum of that midpoint times the frequency, and you're going to divide by the number of values that we have. Okay, the total number of, what are we speaking about in this case? Learners. Okay, these are just all their heights. The 6 learners have a total height of this. Okay, the 23 learners have a total average height of this, and so on. So how many learners were there in total? Well, they told us that there were 250. Okay, Even if they didn't tell you that, all you would have to do is, you see the cumulative frequency, it's already telling you. You could have just totaled it up. We already have that there. Okay. And also at the cumulative frequency, the last number is always going to be the total. So over 250, that's what we're going to do. So I'm going to put the sum of that midpoint over there. So I'm going to add all of these numbers up and see what I get. And when I do that, I get a total of 40,630. That is the total that I get there. So I'm going to say 40,630 divided by 250. And let's see what we get. Okay, and that mean height, estimated mean height is going to be 162.52. And remember, these are in centimeters. So centimeters. And that's how you find the mean height. It takes a lot of work and it's 3 marks. So you need to be careful with your calculation. Okay, so that's what we got. Then the next question, 2.3 says, write down the modal class. So the modal class, you see a word there that you recognize, the word mode. Okay, mode. It's still the mode, but this time they have to call it the modal class because you're not working with single numbers anymore. You're working with group numbers. So it's not a number on its own, it's a class. Now, how would you know what exactly the mode is? Naturally, we know the mode as the number that appears the most. So how do we know which number, which class? Because this is a modal class. How would you know which class appeared the most? Well, if you look at it and you look at the fact that here, look at this class. How many times did this class appear? 6 times, because there were 6 learners that fell within this class. And look at this class. How many times did this class appear? 23 times. So now you see, to find the modal class, the class that appeared the most, you just need to find the class with the highest frequency, because that means there were more people within that class. And so that class appeared the most. So let's look at where the highest frequency in each class is. And that is going to be here at 74. So look at your modal class. That is going to be your modal class. Okay, so write the answer as a class, not the frequency. You need to write the class. X is greater than 160, but less than or equal to. So X is greater than 160, but less than or equal to 165. Okay, most people appeared in this class. Okay, so moving on to the next question. Okay, let me actually just fill in. B is 163. Okay, that's just a cumulative frequency, is not a frequency. Okay, so that's what we have there. And then they say 2.4. On the grid provided below, draw a cumulative frequency graph, an ogive, to represent the data on the height of the grade 11 learners. You see, they're being nice. At least they are giving you the whole grid and you just have to plot down. Okay, so let's draw this curve. Grade 11s. There's one thing I need you guys to remember so that you do not make a mistake when drawing this ogive. It's very easy to draw. So what you're going to do is, first of all, you're going to look at your heights in centimeters, your X values, your classes, right? And whatever number comes first, okay, these are all X values. They will go on the X axis. Now, the Y value that will go with this first number here will always be 0. And this is what I mean. I'm going to take 145 as an X value and Y as 0. So on my ogive, what I'm going to do is I will look at the ogive and I'm going to look for 145 on the X axis. And I see 145 here. My Y value is going to be 0. So I'm not going to move up. I'm just going to stay on here. That stays on the x-axis. You need to always remember to do that. The first value is always going to go with that first, with 0, okay, as the y value. Then remember, this is a cumulative frequency curve, right? So you're not using the frequency, you're using the cumulative frequency. The next value that we have, so let me actually put that together. The next value that we have is 150 now. 150 centimeters is going to go with what cumulative value? It's going to go with a 6, okay? So we're going to have 150 and 6. So Go to 150 and we go up to 6. It's not that high. Around about like, since this is like 1, 2, 3, just go like here, 6. Okay, just pass halfway. So 150 and 6 as the y value. And then to get the next value, so 150 goes with 6. The next value is 155, which is going to go with 29. Okay, 155 and 29. And it's just going to keep going on like that. So 160 is going to go with 89. Okay, it really just works like that. But you just always have to remember that first value there is going to go with 0. Okay, so this whole thing of scrolling up and down is not fun. So I've decided to clip this on the side and let's just use it like this. So the next one we have is, we've put 150, we're done with that. Then 155 and 29. 155 and 29. 29 is very close to 30, so round about there or higher. Okay. And then we have 160 and 89. 160 and 89. So 89, very close to 90. 160 and 89, maybe somewhere there. And then we have 165 and 163. It's quite high. Okay, 165 and 163. So we're going really high there. The next interval, this is 165. 163 is just going to be, here's 160. So 163 is just a little higher than that. Okay, maybe there. And then the next one is 170 and 215. So on the next line, 170 and 215. So we're going higher. 215 is 210, right? And 215 is roundabout in the middle. So there we go. And then we have 175 and 247. 175, 247. So I'm going higher. 175 and 247. So up here, maybe there. Okay, and then we have lastly 180 and 250. So the last one, 180 and 250, right on the dot there. Okay, so there's our cumulative frequency curve. And now we just have to draw it out. So drawing it out is quite simple. It's going to always look like some sort of a curve, as you can see. So just try to keep a steady hand when you do this. So we're going to just connect it like that and go down, down, and like that. There we go. Okay, so there's our cumulative frequency curve, and that is 2.4. Moving on to the next question. Okay, so 2.3 says, use the ogive to estimate the interquartile range of the data. Show all your calculations. So they want us to find the interquartile range of the data, to use the ogive to estimate this. Well, the interquartile range, the abbreviation for it is the IQR. And how do we find the IQR? Well, it's the interquartile range. It is the range of your quartiles. If you find in the range naturally, again, this is revision, you'd say the maximum minus the minimum. But if you want to find the interquartile range, the range of your quartiles, you say the highest quartile, which is Q3, minus the lowest quartile, which is Q1. Okay, so that's how we find that. So we just have to find Q3 and Q1. Well, how do we find it using the ogive? Well, you have to think about it like this. Quartiles work like this. You kind of like have your information, and we've just cut it into 4 parts. And then cut it in half first, and then you cut those halves into 2 parts. So if we look at 1/4 of the data, okay, that's 1/4 of the data. That's going to be Q1. Then if we keep going and we look at 2/4, so this is 2 out of the 4 parts, 2/4 of your data would be Q2. But if you simplify 2/4, you see that 2/4 really just gives you a half. Okay, I'll get to that now. And if you're looking at 3/4 of your data, that's going to be 3 out of 4 parts. That's Q3. So how do we actually find what exactly those values will be, Q1 and Q3? You're going to have to think about it like this. You see, in the previous video that I did, it is the Gauteng paper 2022, that I think they asked for the median. Now the median is Q2. And how I said we calculate that is by saying n divided by 2. And n is just your total frequency, right? You can also look at it like this. You can say n multiplied by a half, because you're trying to find a half of your data. Where is that going to be? So you can think about it like this. If you are looking for Q1, well, Q1 makes up a quarter of your data, of your total data. Okay, so we could have just said n multiplied by 1 over 4, and we'll get that. And if we're looking for Q3, we would say it makes up 3 over 4 of our data, so n multiplied by 3 over 4. And that's how we'll find it. We'll find the position of these like that. Okay, so that's really what I'm going to work with first, finding where exactly they will be. Okay, so let's work on Q1 first. We're saying Q1 is equal to n times 4. And remember, n is your total frequency. So I'm saying to find the position, is still the position, Q1 position. I'm going to say my total frequency. And what's the total frequency? Well, they told us that there are how many learners? The total frequency is 250. And we can even see it here in the O drive. That's the last value we have. It's 250 over there, okay? That's 180. So 250 multiplied by 1 over 4. This will give us the position. So remember, I just said a cumulative frequency value times 1 over 4. Okay, let's just see what this gives us first. So we get 62.5 as the position of our Q1. And this is what I mean by that. I said the cumulative frequency times a quarter, right? So this value that I have, to find exactly the value of Q1, I'm going to have to go to my O drive and look at 62.5 on the cumulative frequency axis, okay? Because I just said the cumulative frequency times 1 over 4. So whatever answer I get here is still a cumulative frequency value. So 62.5, I'm just going to go here, 62.5, I'm going to look, where is that roundabout? This baby roundabout here, okay? And I'm going to keep going to the O drive, and once I touch the O drive, I stop, and wherever you touch the O drive, I just feel like it's lower than this, a little lower. Okay, so once I touch the O drive, I'm going to just go down and see what X value is this roughly about. Okay, so, okay, where that is. It looks like it's right in the middle. So I'm going to estimate, and that's probably why they said the estimated. It's going to be like 158. That's what I'll say, because it's in the middle. Okay, so I'm saying the value of Q1 is approximately 158 centimeters. Okay, because that is in centimeters. So the first quarter, the first quarter of your data is going to be 158 centimeters and lower. That's where the first quarter of our data lies. Then to find Q3, we're going to do this and say n multiplied by 3 over 4. So n again is 250 learners multiplied by 3 over 4. And let's see what we get there. So I'm going to change that to 3 over 4. And I get 187.5. 187.5. So I have to go to the 187.5th learner and check what centimeters that is going to be. Again, this is the position. It's not the Q3 yet. We'll find the Q3 like this. So go to the O drive again. On the y-axis, go to 187.5. 187.5, here's 180. 87 is closer to 90. So I'll say around about maybe here. And keep going to the O drive. And once you touch the O drive, you stop and you start going down to see what number this is. It also looks like it's roundabout in the middle again. So since this is 165, 170, I'll say it's 168, roundabout there. Okay, so that is Q3, 168 centimeters. And now finally, to find the IQR, we're just going to say Q3 minus Q1. So let's go ahead and do that. Q3 minus Q1. So the IQR is going to be equal to Q3, which is 168 centimeters, minus Q1, which is 158 centimeters. And so that's going to be equal to, as you can see, 100 and 100 cancel, 8 and 8 is gone. 60 minus 50 is 10 centimeters. That's going to be the IQR, roughly. I'll say approximately that. Okay, so that's the IQR using the O drive. Okay, so what's going to usually happen is they'll have a range of answers that they're going to accept. So they were like, within this amount would probably be right. So even if you're just one off, it's still going to be fine and it will work out fine. Okay, So that is the end of question 2, and then we move on to analytical geometry in question 3. Okay, so now we're on question 3, and question 3 says, in the diagram below, the vertices of triangle AEC are A, C, which is 4 and -4, and E, which is -6 and -9. Then they tell us that the angle of inclination of AC is alpha, and ACE, angle ACE, is equal to beta, okay? And then the equation of AC is 3x plus y minus 8 is equal to 0. Okay, so the first question is to write the gradient of AC. Well, what did it tell us about AC? As you can see, we don't have A, we do have C. However, they told us that the equation of AC is 3x plus y is equal minus 8 is equal to 0. So let's put that equation down first. So we have 3x plus y minus 8 is equal to 0. So as you can see, it's not in standard form. It's not in the form of y is equal to mx plus c. So you have to get it into this format, meaning you need to leave y alone on one side. So if we leave y alone, this is what's going to happen. We leave in y, and we're saying it's equal to. We're first of all going to take over the 3x because it needs to be in the form of mx plus c. So it comes over and becomes negative 3x. And then we'll take over the negative 8, which becomes a positive 8. So it means that the gradient of AC is actually equal to negative 3, because that's mx plus c. So that's m. Okay, so negative 3. Okay, moving on to the next question. And next, 3.2, they say calculate the size of alpha. Size of alpha. So alpha is over here. As you can see, it's going from the x-axis to the line AC. So it's just the angle of inclination of AC. So to find the angle of inclination, you just need the gradient, because the formula for finding angle of inclination is tan of theta is equal to the gradient. But what is the gradient of that line AC? The gradient, we already found that it's negative 3. So tan theta equals negative 3. And then we're going to say theta is equal to, and we're taking tan over really. We're getting the inverse of tan. So that is shift tan, the second function of tan. And we have negative 3. Then I'm going to say, because looking at this line, right? Looking at AC, it is a line that is decreasing. It's a decreasing function. That's why its gradient is negative. The angle of inclination, do you notice that this angle is an obtuse angle? Okay. If you just say shift tan negative 3, right? Look at what you're going to get on your calculator. Shift tan of negative 3 gives you this. Negative 71 point, and then it keeps going, right? Now, it's not like unimportant. This is actually, it is important, but then I just want you to see that it's actually measuring the angle backwards like this. It's measuring this angle. So that is that negative 71, okay? But we don't want that. We want the obtuse angle. So in order to get that, you have to say plus 180 degrees. Okay, so if you say plus 180 degrees, you're going to get theta being equal to 108.43 degrees. Okay, so that's one way of doing that. You could have also done this instead. You could have taken the fact that, tan of theta is equal to negative 3, then take tan over. But then when you take tan over, you say shift tan of 3, right? Or rather, you're going to say 180 degrees minus second function of tan. Then you put positive 3. So the absolute value of whatever this is. Okay, so you could have done that. But you see, even if you did that, you will still get the exact same answer. See, if we say 180 minus shift tan of 3, you see that we still come to the same answer. That's why I like to use this method, because instead I just say shift tan of that, and then I just add 180 degrees. So we still get to that obtuse angle. Okay, so that is our answer, and we can move on to the next question. Okay, so the next question, they say calculate the size of beta. Okay, let's look at beta. The size of beta. Okay, I want to actually put down the angle that we have there. We have 108.43. 108.43 degrees, but they want us now to calculate the size of beta. When you are calculating an angle that is clearly not an angle of inclination, this is what we're going to do. So I know that's not an angle of inclination because it's not going from the x-axis, okay, to a line. It's kind of formed by two lines, okay, intersecting. It's not being formed by the intersection of the x-axis and the line. So I have to find out how this line was created, how this angle, was created. Angle beta, how is that created? How you find out that is, you see the point of where the two lines, right, AC and EC intersect. At that point C, that's where this angle was created. Because those two lines intersected at this point, these two lines, help to form this angle. So what you're going to do is, at this point, you can draw an imaginary x-axis. This is my way, at least, of doing this, right? I draw an imaginary x-axis, so it will be parallel to the original x-axis. And then, like this, I'm going to find out how this angle was created. Okay, so I'm seeing numerous ways of doing this. You have to actually really be creative with the way you find this. So we want to find this angle over here. So look at one way of doing this. I could take the line EC and I could extend it. That's another thing that you can be doing, extending lines so that you can understand the full length of the angle that it creates really. So if I take EC and I extend it, right? Let's see what happens. Now, do you see that here we have a straight line? The angles on the straight line add up to 180 degrees. So it means that in order to find angle beta, if I find the angle over here, I'll be able to find angle beta. So this is one method that I'm using, right? I will try to look at different methods that this could have been, worked out with. Okay, so that's what I could do at first. I could try and find this angle. So how do we get to that angle? Okay, getting to this angle, I'm seeing a way we can do that because we've extended this line. Why don't we, since this is our x-axis, right? Why don't we find theta first of all of this line AC? So look at what theta of AC is going to look like. And it's probably what they want because I see now that we already have that though. Theta of AC goes from the x-axis to the line. And you see that we already found that from the x-axis to the line of AC. That is theta of AC. And so it means that this angle will be exactly the same thing. It's also going to be 108.43 degrees. They are the exact same thing because I drew an imaginary x-axis. Okay, that's another x-axis that I'm drawing. It's parallel to that. So if we have this, I have 108.43 degrees, right? And I just want to find this angle in between. I want to find this angle over here. How do I find that? Well, I could take that angle, and if I subtract it by this little angle over here, see, from the x-axis to this line of EC, right? That is the angle of inclination of EC. Then I could find this angle. Then I could use the sum of angles on a straight line to find beta. Okay, and that's how I'm going to do this. It seems more clean. The other method I was thinking of is a little bit messy, but it will still get to the answer. Okay, so we already have that. We just have to find this angle over here, the blue one. And we're just going to call that, I will call that theta of, and the line that it is speaking about, theta of EC, because it goes from the x-axis to the line of EC. So that's theta of EC. That's what we need to find. Okay. In order to find theta of EC, what do we need? You want to find the angle of inclination of EC. You need EC's gradient. And this is perfect because look at this. We have E, we have C. We can find the gradient using the coordinates that we have. So I'm going to write down those points. I know that E is -6 and -9, and C is 4 and -4. Okay, I'm looking at it also on a page as well. So I'm going to say the gradient of EC is going to be equal to y2 minus y1. So imagine, you can also say -9 minus -4. It's still fine. Okay, as long as you stay consistent, and also say -6 minus 4. Okay, so I'm going to say -9 minus -4, but if you look at that negative and the negative multiply and they will become a positive. So that's -9 plus 4 over, so that's y2 minus y1, -6 minus 4. Okay, this is not a -4, so that won't change to positive. Just -6 minus 4. And let's see what this gives us. And I get a half. So 1 over 2 is the gradient of EC. And now because I have the gradient of EC, I can finally find the angle of inclination of EC. Okay, so the angle of inclination, you say tan of theta is equal to the gradient, which is a half. So theta of EC specifically is equal to, I'll take tan over, so the second function of tan, and then a half. Let's see what we get here. So shift tan of a half, shift tan of 1 over 2 is just 26.57. Now, technically you don't really have to round off because we already have this other one and it's already rounded off to 2 decimal places. Yeah, you can. Even if you round off, it's not going to affect it in this situation. Okay, because this is already as 2 decimal places. But to be safe, you can just take like 4 decimals as well. Okay, so I'm just going to say theta of EC is equal to, and I get 26.565. Okay, 5650, and it keeps going. And then now that I have theta of EC, I want to find this angle in here, in between. Okay, and I'll find that angle. Let's say we just call it angle C1. Okay, if I want to find that angle, I'm going to find it by saying it is equal to this larger angle minus this little angle. And that's going to leave me with this piece over here. Okay, it's like taking this entire piece and removing from it this little piece. And so you'll just be left with this part. Okay, so that is the 108.43 degrees minus the theta of EC. Okay, so that's what we're going to do there. So to find that angle, okay, as long as you get the right answer at the end, it's going to be fine. So angle C1, that's what I'm just calling that, is equal to 108.43, right? 108.43 degrees, yes. And then minus the 26.5650. So I can just use the button and to be sure so that I don't round off. Okay, so it's equal to that, right? So I'm just going to say 108.43 minus ounce. And there. So when I do that, I get 81 point, and then now I can, well, you can round off to 2 decimals, it will be fine. The reason why is because I know we're trying to find beta, but we're going to use angles on a straight line to find beta either ways. So you're going to still have to say 180 degrees minus that angle. 180 is already a whole number. It's not in decimal form. So you rounding off here is not going to affect your answer. So I would already round off at this point here. Okay, so 81.86 degrees. And then now that I have C1, I can go ahead and say, okay, I've got this angle here as 81.46 degrees, right? And so to find beta, I'm looking at the fact that we have angles on a straight line. The angles on a straight line add up to 180 degrees. So to find beta, I will say beta is equal to 180 degrees minus that 81.46 degrees, okay? And that's how I'll get to the answer. So there, 180, I'm just going to say beta, therefore, beta is equal to 180 degrees minus 81.86 degrees. Okay, so beta is finally equal to, I'll say is equal to, and then if I say 180 minus ounce, it's still going to give me my answer, but even if you round it off, it will still be fine. Okay, so that's going to be 98.14, okay, degrees. And there we go. That's our final answer, rounded off to 2 decimal places. And that was for 5 marks. So that's some way you can really score marks. Okay, so that's one way of doing it. The other way would have been really messy. I don't want to actually work through that way. So I'll kind of just like show you a demonstration of what it would have looked like. So the other way that I was going to use is this. I would have still left the imaginary x-axis, but what I was going to do is find the angle of inclination of this line AC, right? The angle of inclination of that line AC, but then you know that in order to do that, you need the gradient of AC. We already have that. The gradient of AC was, I think it was -3, right? Yeah, -3. So the gradient of AC was -3. if you had said shift tan of -3 immediately without adding 180 degrees, you see shift tan -3, you would have gotten -71.56 and then 5 degrees, right? That is because this angle is measuring backwards. It's not measuring like the way normal angles go. Normal angles, you measure like this. That's anti-clockwise. This is measuring the other way around. It's measuring like this. Okay, that means this, that should have been this angle of inclination, it's not measuring that. It's measuring this part from the x-axis to the line of AC, but backwards, the wrong way of measuring angles. So the size, the absolute value, the actual size of this part would still be 71.57 degrees. See, then I got a little part of it. I got this little part of it. I'll still have to get this part of it. And it will really just do a similar thing as well. So in this one, if I extend this line again, yeah, I actually do need to extend it. You would see that if you found the angle of inclination of EC, do you see that? Look at these two lines, right? The line of EC and your x-axis. Do you see that they intersect? And these are now vertically opposite angles. Vertically opposite angles are equal. So whatever the angle of inclination of EC is going to be exactly that value. Then if you added this angle with this angle, you would get the full size of angle beta. Okay, so that's the other way of doing that. It's a little messy, but it really helps you to understand how all of these are actually still important. Okay, so that is that. We already found that answer, and now moving on to the next question. So key beta, it's going to probably come in handy. Okay, moving on to the next question. Okay, question 3.4 says, determine the equation of EF if F is a point on AC produced such that EFA, angle EFA is equal to 90 degrees. Okay, let me pin this to the screen so that we can see what's actually going on. So they want us to determine the equation of EF if F is a point on AC produced. Okay, F is a point on AC produced. So somehow AC is produced, and so I guess it's going to be because AC in alphabetical order. Then if it's produced, we're moving like this. Okay, so then we have the point F, right? It's on AC, the production of AC. But then they say such that EFA is equal to 90 degrees. So angle EFA. So if you go EFA, it forms a 90 degree angle. So I connect E and F and they form a 90 degree angle. Okay, so that's what they're asking for. And let me actually put these in red so we can easily see them. Okay, so this is what they're saying. So we have to determine the equation of EF. So how do we find the equation of EF? This is EF. So we have 1 point and we have F. We don't have F. If we just know that AC, right, and EF form a 90 degree angle, or rather AF and EF form a 90 degree angle. Okay, so since we need this equation, in order to find the equation of a line, you need two things. You need a gradient and at least 1 point on the line. We have 1 point on the line, we just don't have the gradient. And that's definitely why they told us that EFA was equal to 90 degrees. So we're going to have to use what we know about perpendicular lines. You see, because EF is perpendicular, so EF is perpendicular to the line AF, right? This is what it means about their gradients. It means that if you take the gradient of EF and you multiply it to the gradient of AF, that is going to give you -1. That's what it means. So with this equation, we can actually find the gradient of EF that we want. We want the gradient of EF. We can actually find it using this equation. All we need is the gradient of AF. Okay, do we have the gradient of AF? Yes, we do, because we have the gradient of AC. Okay, because AC is collinear. AC and F, they're all collinear. They lie on the same line. It means whatever the gradient of AC is going to be the exact same gradient of AF. So what we're going to do is go ahead and see what exactly was the gradient of AC. So because I'm saying the gradient of AC is exactly the same as the gradient of AF because they're collinear. So it means the gradient of AF is, let's check what that gradient of AC was. The gradient of AC was -3. Because remember, the gradient of AC, yeah, it's -3. So that is -3. So all we would say is the gradient of EF multiplied by the gradient of that, which is -3, the gradient of AF, sorry, I said EF, times the gradient of that, which is -3, is equal to -1. Okay, so like this, all we're going to do is we're going to make this the subject of the formula. How do we make this the subject of the formula? By getting rid of the -3. How'd you get rid of the -3? Well, it's been this that we want to leave alone is being multiplied by -3. So to remove the -3, you would have to divide by -3 on both sides because it's an equation. Then it means, therefore, that the gradient of EF is actually equal to -1 divided by -3 is 1/3. That's the gradient of EF. Okay, so let me put this all down first and then we continue with this. Okay, now that we have that gradient, we just have to find the equation of EF. Okay, so how do we find the equation of EF? Remember how I said that in order to find the equation of a line, all you need is its gradient and 1 point. We have 1 point. We have -6 and -9. So we can actually just find the equation of the line. You can use, and let me just write that point down so I don't forget, -6 and -9, right? That's what we have. So you have two ways of finding the equation of a line. You can either use the normal standard form of a line, y is equal to mx plus c, then you substitute your m and then substitute your point. It will help you find c, then you just put it back into the equation. But I like to use this method where I just say y minus y1 is equal to the gradient multiplied by x minus x1. Okay, please note that x1 and y1 are your x and y coordinates of the point you're substituting in. So all I'm going to do here is I'm going to say y minus what's y1? Y1 is -9. So minus -9. Well, if you multiply that in, that's going to become a +9. So plus 9. And then that is equal to, our gradient is 1/3. So 1/3. And then we're saying x minus -6. Minus -6 again becomes a positive because of negative times negative is positive. So we're going to say plus 6. Okay, and this is the reason I like to use this formula. Okay, it's because of this. I can simply just go ahead and distribute the 1/3. 1/3 multiplies into x and into 6. So if you say, I'm going to say is equal to 1/3x, when it multiplies to x, and when it multiplies to 6, 1/3 times 6 is the same thing as, you can put it on the calculator, but it's 6/3, which will give you 2. So then that is +2. Then over here now, I'm going to say that I'm leaving the y on this side, and I'm going to take the +9 over, and it will become a -9. So we have y is equal to 1/3x. 2 minus 9 is -7. So there we go. That's our equation of that line of EF. So there we go. Equation of line EF. And now we move on to the next question. Okay, so the next question, 3.5, says, calculate the length of EF. Okay, the length of EF. We found the equation of EF in the previous question. Now we need to find its length. To find the length of EF, right? Just looking at the way this looks. And that question was for how many marks? It was for 5 marks. Okay, so in order to do this, I was first of all thinking maybe they're just trying to, spice this up a bit and make us use Pythagoras because we have a right angle triangle. But now I don't think so. The reason why is because we don't even have A. So there's no way we can even find the length of the hypotenuse. We can't also find the length of AF because we don't know what F is. So everything here just leads to us having to find the coordinates of F. So we actually have to find the coordinates of F. That's not going to be a problem because we actually have the equation of line AC, okay? And the equation of line AC is going to be exactly the same as the equation of line AF. Again, they are collinear. Okay, it's the same line, it's on the same line. But that does not mean the length of AC is the same thing as the length of AF. Those are two different lengths. Length is a measurement, okay? It's not about the equation of it. So all I'm going to do here is I have the equation of line AF technically because I have the equation of AC. And if I use that equation and I equate it with the equation of EF, which we do have, I'll be able to find their point of intersection. So if I equate the equation of EF with the equation of AF, I will find the point of intersection F. So that's what I'm going to do. So I need the equation of AF, which is the same equation as AC. We already put it in standard form, so I'll use it like that. The gradient of AC, well, we wrote the equation in standard form, y equals negative 3x plus 8. So that's the first equation we have of AC. We have y equals negative 3x plus 8. And of EF, we found the equation of EF in the previous question, I think. Yes, here, right? The equation of EF is y equals 1 over 3x minus 7. We have that already. So if we just equate them, then we'll be able to find the equation of, we'll be able to find the point F. So I'll just say y is equal to y. And so that is negative 3x plus 8 is equal to 1 over 3x minus 7. Put the x's on one side. So I'm just going to take that over because it's negative. I'm going to say 1 over 3x plus 3x is equal to, and then I have positive 8, and I'm taking that over, so it becomes positive 7. And then 7 plus 7 is 14 plus 1 is 15. And then we have this. Okay, you can put this on the calculator. You can also just calculate it manually. So I'm just going to say that becomes a 9 over 3x. Okay, that's 3x. And so 9 plus 1 is 10. 10 over 3x. Okay, you can also use a calculator. Then I need to solve for x. So I'm going to divide both sides of the equation by 10 over 3. 10 over 3. And then, yeah, x is finally equal to, and then we can just find the answer. And we have 9 over 2. Okay, so that is it. As a fraction, I like leaving things as fractions because I feel like it's just put together. So that's the x value. Now we need to find the y value. You can take this x value and substitute it into the equation of AC or even into the equation of EF, because either ways, the point F lies on both lines. So I'm going to say y is equal to, and I'll take the easier one without the fraction. So negative 3 bracket 9 over 2 plus 8. And then we just substitute that and get our y value. Okay, and we get negative 11 over 2. Okay, so we have the x and the y value now. So it means that therefore the point F is 9 over 2 and 11 over 2. Sorry, that is negative. Okay, so now that we have that, we just need to find the length of EF. Since we have the coordinates of F, we just need the coordinates of E. Okay, we have the coordinates of E over here. So E is negative 6 and negative 9. And F is just this again, so I don't really need to write it again. The equation for the distance of a line, we're saying EF is equal to the square root of, and you're going to say x2 minus x1 all squared plus y2 minus y1 all squared. And this is equal to, so the square root of the x2. So you can start with anyone as x2. But if you say this, if you say x2, sorry, minus x1, then you need to also say y2 like that, minus y1. Okay, so I'm just going to say negative 6 minus 9 over 2, all squared, plus, and then negative 9 minus negative 11 over 2. So negative 9 minus negative 11 over 2. Please remember that's going to become a positive. So it's really negative 9 plus 11 over 2 all squared. Okay, so let's go ahead and see what EF is going to be, the distance of EF. And we get 7 square root 5 over 2. I feel like my calculator is just making that look weird. Okay, but that's what we get. And so as decimals, round off to 2 decimal places. Okay, like they mentioned in the instructions, that will be 11.07 rounded off to 2 decimal places because the 7 rounds up. So 0.7. Okay, and this is in units because they didn't really give us any of the things in any unit of measurement. So it's going to be in units. Okay, so there we go. That is the length of EF. Okay, moving on to the next question. Okay, that is actually the last question for that question 3. And then we move on to question 4, which is on more analytical geometry. Okay, so question 4 says triangle PRS has vertices P, and then those are the coordinates R and S. And as you can see, S is missing, as shown in the sketch below. Okay, so the first question is for us to calculate T, the coordinates of T, the midpoint of PR. Okay, so we have PR, and in the middle of it, we have this coordinate T. That's what we have to find. So we've been given the coordinates of P and R. We can just use the midpoint formula to find the midpoint. Okay, so I'm going to take this as x1, and that's x2, and that's y1, and that's y2. So we're just saying the midpoint, okay, or T is now going to be equal to x1 plus x2, and then over 2. Then we have y1 plus y2 over 2. Okay, so that is going to be x1 plus x2, that is -1. So as you can see, you don't even need the formula. That's why they just give in 2 spaces. So I'm saying -1 plus 3 over 2. -1 plus 3 over 2, and then y1 plus y2 over 2, which is 3 plus -1. So 3 plus -1 is just going to give you 3 minus 1. So that's 3 minus 1 over 2. Okay, so let's simplify. 3 minus 1, so I'm just saying -1 plus 3, that is going to be 2. 2 over 2 just gives you 1. And then 3 minus 1 is also just 2 divided by 2, which is 1. So T is 1 and 1. That's what we have. 1 and 1. And that's our midpoint, T. Okay, moving on to the next question. Then the next question says 4.2. If the perpendicular bisector of PR passes through S, show that A is equal to B. Okay, if the perpendicular bisector of PR passes through S, the perpendicular bisector of PR, the line that cuts this line into 2 equal parts, right? And it is going to be perpendicular as well to PR. So the perpendicular bisector, it cuts through S. So it means this is what's going on. We have a line, right, cutting through or bisecting this line PR, okay? And it also cuts through S, as we can see. But because it's a perpendicular bisector, it's going to be perpendicular, first of all, to this line PR, and it is a perpendicular bisector. To bisect means to cut into half, okay? 2 equal parts. So that now means, of course, we know that this is equal to this, and that was already true because T is your midpoint, okay? So that's really what they're saying. We just have this line here, and we have to show them that A is equal to B, so that the A value is equal to the B value. Okay, so given that ST, right, is the perpendicular bisector of this line, PR is a perpendicular bisector, then it means that these 2 lines are perpendicular, right? So what does that mean? It means that the gradient of this first line, PR multiplied by the gradient of the perpendicular bisector, ST, right? And when you multiply them, you're going to get -1. So it means with that, what we can actually do is we can find the gradient of PR, which will be easy to find. We have both coordinates. And we can use that to find the gradient of ST. Now, why do we need the gradient of ST? Well, because we're trying to show that A is actually equal to B, it may not necessarily mean we have to actually find these values. Because if you look at it, how do we find the values? We can't actually find the values right now. We can, however, find the equation of this line. So when we find the equation of this line, what we can do is we can substitute the value A, the X and the Y value, into this equation in place of X and Y. And if the equation balances out, right, like that is equal to that, we're probably going to end up with A being equal to B. And so we'll be able to see that, oh, okay, they're actually equal. We're using the fact that they said that this is a perpendicular bisector. Honestly, I was initially going to find the lengths of these 2 lines, okay, and I knew it was going to include A and B, and then I was going to get an equation that's going to look very similar, the equation of that one and the equation of that one. So it was going to show that A and B are exactly the same. But because of the fact that they purposely just pointed out about that perpendicular bisector, I'll go through using this method instead. Okay, so first of all, I'll need the gradient of PR, which I can find using its coordinates. So let's find the gradient of PR first. So gradient of PR is going to be equal to, so P was the coordinates, P is -1 and 3, and then R is the coordinates 3 and -1. Okay, so y2 minus y1. So I'm just going to say -1 minus 3, -1 minus 3 over x2 minus x1, 3 minus -1, which would be a 3 plus 1. And so -4 over 4, -4 over 4, just going to give you -1. So the gradient of PR is -1. And so because you know that if you multiply the gradient of PR, the gradient of ST is going to give you -1. Think about that. If this one is already -1, the gradient of PR is -1, what must you multiply it by to get -1? You must multiply it by 1. So it means that the gradient of ST is 1. Okay, so I'm going to say, therefore, this means that the gradient of ST is equal to 1. That's using the rule of perpendicular lines. Okay, now that I have the gradient of ST, I can find the equation of ST. I have its gradient and I have a point on ST, 1 and 1. So I'm going to use the y minus y1 is equal to m bracket x minus x1. And so y minus, remember, t is really just 1 and 1. So y minus 1 is equal to the gradient, which is 1, and x minus 1. And so this is equal to, multiply that in, that's x, multiply, that's -1. And we're taking -1 over and becomes a +1. Y is equal to x. Okay, that's what we get. The equation is y is equal to x. So if we take this coordinates, the x and the y coordinates of S, right, which is S is A and B. If you substitute it into this equation, the y value is B, the x value is A. So that means B is equal to A. And there we go. We have proved that A and B are equal. Okay, so that doesn't, of course, solve for the actual values of A and B, but it does show us that they're going to be equal. So it's going to be the exact same number. Okay, moving on to the next question, 4.3. Okay, then 4.3 says if A is less than 0 and B is less than 0 and the area of triangle PRS is equal to 12 square units, determine the coordinates of S. So they actually want us to find that A and B value now. Well, we do remember that they're exactly the same. Okay, so let's just keep that in mind. But they told us that the area of triangle PRS is 12 units. So let's look at that. The area of this triangle PRS, okay, it's 12 units. So since they're giving us the area and they want us to find the coordinates of S, meaning solve for A and B, we're going to have to use the formula for the area of this triangle. Now, because we already have a perpendicular bisector, this is going to serve as the height of the triangle. It's from the highest point to the perpendicular base. Okay, so that's our height. The area of a triangle, okay, with a perpendicular height is always going to be a half. So area of a triangle is a half multiplied by the base multiplied by the height. Okay, so let's establish what is what here. So we're going to say we have the area, of course, we'll put that down. That's 12 units squared. And we have a half multiplied by our base is PR. That's our base. PR multiplied by our height, which is ST. ST. This is what we have to do. And we need to solve for A. Okay, A and B really. But A is B, so it's going to work out like that. Okay, so let me put this down first. Okay, so now that we have this down, all we really need to find is what exactly that PR, the length of that is, and the length of ST. Okay, this one is definitely going to be in terms of A and B, or just A alone, okay, because A is equal to B. So let's go ahead and find that length of PR first. I'll just do that on the side and then put all the other answers down here. Okay, actually doesn't matter, it's fine. I'll just put it here. So I want to find the length of PR. It's going to be equal to the square root, and P, I'm just going to be looking on my screen here. P is -1 and 3, and r is 3 and negative 1. Okay, so all I'm just going to say is x2 minus x1. So I can start like this minus that. So I'm going to say negative 1 minus 3 all squared plus y2 minus y1 all squared, which is 3 minus negative 1, which of course becomes a plus 1. So 3 plus 1 all squared. Okay, and I'm going to put this onto the calculator and see what it gives me first. Okay, and it gives me 4 square root 2. So PR is equal to 4 square root 2. So I have that now. Now all I have to find is an expression for the length of ST. And I'm saying expression because ST had A and B in it. Okay, so it's not going to be a simple, nice looking number. So we have ST is equal to, again, x2 minus x1. So remember that S was A and B. But I know that A and B are equal. So I'm just going to put this in terms of A. I'm going to call S A and A because they have the same value. And the reason I'm trying to keep it like that is I don't want two variables to be there. Now that I already know they're equal, I don't want to have two variables working with them if they're already the same thing. We can just focus on it being one variable. If we find A, we will know what B is. Okay, so this is S, and then T was that midpoint, 1 and 1. Okay, so the distance of that. Again, x2 minus x1, I'll just start here. That's A minus 1. A minus 1 all squared plus y2 minus y1, and then A minus 1 again all squared. I have the same thing here. Okay, so that's what we have here. So let's look at this. Can you simplify it further? ST, we can actually simplify this further. You see, if this was A plus A, it will just give you 2A. So you see that this is 1 minus A minus 1 all squared, right? Plus A minus 1 all squared. It's the same thing as kind of having x squared plus x squared. It will just give you 2x squared. So I'm going to just put a square root still, of course. So square root, but then I'm going to have, let me erase those, square root, and then I'm going to have 2 because I'm adding them together, but I still have A minus 1 all squared. Okay, so that's a way of simplifying it to just make it look more simple. Okay. Okay, so now we have PR and ST, and we can come back to the equation of this formula. So I'm saying, therefore, 12 is equal to a half multiplied by PR, which we now know is 4 square root 2, multiplied by ST, which we now know is the square root of 2 multiplied by A minus 1 all squared. Okay. So that's what we have. And we basically just have to try and solve for A. Okay, so we need to simplify safely. I'm going to go ahead and multiply the half with the 4 square root 2 first. So if you say a half multiplied by 4 square root 2, you get 2 square root 2. So 12 is equal to 2 square root 2 multiplied by, and then we have the square root of 2, A minus 1 all squared. Okay. Okay, now because I notice I have a 2 here, and I know these are square roots, so they may be able to work together because the square root and a square root. So because I have the 2 here, and this is one single term, okay, it's one single term because there is no plus or minus sign in between to separate it. There's a multiplication sign, so this is one term. Terms are separated by only plus and minus signs. So I can get rid of the 2 by dividing both hand sides by 2. So 12 divided by 2 is 6. But here, when we divide all of this by 2, it's going to cancel out that 2 over there. So now we're left with the square root of 2 multiplied by the square root of 2 bracket A minus 1 all squared. Okay, so now that we are at this point, what we can just do is we're saying, okay, so this is the rule that I want you to now realize. You see that you have a square root being multiplied by a square root. When square roots are being multiplied, this is how it works. For example, if I say the square root of 3 multiplied by the square root of, let's say, 7, I can rewrite this as, because they are both square roots, okay, this doesn't work with square root and cube root. Only square root and square root, as long as the root is the same. So I can say this is the square root of 3 multiplied by 7. That's how we can actually rewrite that. So the fact that you have two square roots multiplying, I can say 6 is equal to, and I'm going to put them under one square root. And I'm saying it's the 2 being multiplied by the 2 bracket a minus 1 all squared. Okay, so 6 is equal to, and now we're going to have, what's going to happen here? You see, the brackets is being protected. So it's really the 2 and the 2 that's going to multiply. We have the square root again, and then you have 2 times 2, which is 4. 4, and then bracket a minus 1 all squared. Okay, let me leave that radical in blue. Okay, so this is what we have so long. And we just need to solve now for a. How do we get into a? Well, right now, we have a square root of 4, okay? I would have said square both sides, but I'm starting to see that, hey, this is a square root of 4. That can simplify. Now, please notice, if you have something like square root of 4 plus 5, or let's say plus a, you're not allowed to say, oh, the square root of 4 is 2, because there's a plus sign here, meaning these are two separate terms. And so you cannot just square root like that across terms. I know that, yes, if I square root the 4, the 4 is a normal number. I can just square root that. That's fine. That's just going to be 2. And then still in that root, in the radical, I'm going to have a minus 1 all squared. And then I still have 6 here. Then I can get rid of the 2 by dividing both sides by 2. And now I have 3 is equal to the square root of a minus 1 all squared. Okay, so now that we have square root of a minus 1 all squared, then I can get rid of this root first. Get rid of this root by squaring both sides of the equation. Okay, and then if we do that, let me just continue on this side. We're going to get 9 is equal to, and then what happens here is this square root cancels with that square, right? And so you're left with this a minus 1 squared inside under the radical. So a minus 1 all squared. Okay, now that we have this, we can solve for a. So to solve for a quickly, you can get rid of the square root by square rooting both sides. But remember, when you square root both sides, the highest exponent of a is 2, meaning you have two possible solutions. If you square root both sides in front of the number, okay, because this is the number, this is what you're solving for. You don't put this in front of wherever the variable is. We need to put plus and minus here. So this is now going to be positive or negative. What's the square root of 9? That's 3 is equal to, and we have a minus 1. Then I'm going to take the negative 1 over, and that's positive 1 plus or minus 3 is equal to a. So this means that a is either equal to 1 plus 3, or a is equal to 1 minus 3. Okay, so there, now we're going to have our two solutions because the highest exponent of a was really 2. It was a second degree equation. Okay, so this is a is equal to 1 plus 3, which is 4, or a is equal to 1 minus 3, which is negative 2. Okay, so this is what we have. We have a is equal to 4, a is equal to negative 2. Which one will be our solution? Well, they told us that a and b needs to be negative. So that brings us to taking this answer. So that's not our answer. This is our answer. A is actually equal to negative 2. So it means now, because we knew that b and a were equal, it means that even b is also equal to negative 2. So the coordinates of S, what they were asking for, okay, determine the coordinates of S using that area, is now going to be negative 2 and negative 2. Okay. So that was the last question, and that's probably one of the most challenging ones throughout so long, okay, because of the arithmetic behind it. Okay, so that is 7 marks, and that is the last question for question 4. And then we move on to question 5. Okay, so question 5, in question 5, this is what they say. If sine of 33 degrees is equal to m, determine the following in terms of m without the use of a calculator. So this is a common one that they would ask, even in grade 12. Sine of an acute angle is equal to m. Well, think about this angle 33 degrees. It's acute. So on your cast diagram, which quadrant would it lie in? Because it's an acute angle, this is an angle that is less than 90 degrees. So it's going to lie in the first quadrant. Okay, so it's going to look like this really. You have your first quadrant, and in that first quadrant, you're going to have your radius. And then if you match that down to the x-axis, it's going to be perpendicular to the x-axis. And then you're going to have the angle 33 degrees here. So what are they actually saying? They are saying that you have sine of 33 degrees being equal to m. So let's think about what that's going to be. Sine, right? 33 degrees is equal to m. Well, as a fraction, we can put this as, or you can think about what sine is. Sine speaks about the opposite over the hypotenuse. So it's really saying opposite over hypotenuse. So we can clearly see the opposite side is going to be m. But what's the hypotenuse going to be? What is the denominator of m? Well, if m doesn't have a denominator, it's actually a 1. So now we know the hypotenuse is going to be 1. And your opposite side is going to be m. So here's 33 degrees. Opposite 33 degrees will have m. And so we just have to find, in order to be able to solve or answer every question on this, we need to solve for that adjacent side, which we call x, because it's going to be an x value. Okay, so I'm just going to say x squared is equal to, and I'm going to take the hypotenuse squared, which is 1. So 1 squared, and then I could just say 1 squared, minus this m squared, okay, minus the opposite side. And so now if we solve for x, you could square root both sides. But you know that if you say 1 squared, that just gives you 1. So x is finally equal to, you could have said plus or minus, but the thing is it's in the first quadrant. So we know that it's definitely positive. The x value is positive in the first quadrant. This is a positive x value we will have here. Okay, so this is going to be the square root of 1 squared is 1 minus m squared just stays m squared. So that's what we have here, the square root of 1 minus m squared. So tan of 33 degrees is going to be the, what tan is always going to be TOA, which is opposite over adjacent. So you take the opposite over the adjacent side. So tan of 33 degrees is equal to the opposite m over the adjacent, square root of 1 minus m squared, and that's your answer. Okay, next one, cos 777 degrees. The thing about these angles is they're all going to relate to 33 degrees in some way, because your diagram is using 33 degrees as your reference angle. So let's go ahead and find cos 777 degrees. Well, first of all, looking at this angle, I can see that this angle is way bigger than 360 degrees. So there's a general rule that works like this. If your angle is greater than 360 degrees, what you need to do is subtract 360 degrees from it. And if your angle is negative, okay, less than 0, what you need to do to it is add 360 degrees. So let's keep that rule. So the angle here is way bigger than 360. So we need to remove a 360 from that. So it's like 777 minus 360. And you see what it gives us. That angle is still greater than 360. You have to keep removing 360 from it until it becomes an angle that is not greater than 360. So I would say minus 360 degrees, and that gave me 417 degrees, right? The cos of 417 degrees. Then I'll remove another 360 degrees from that again. Okay, minus 360 again. And now I get 57 degrees. Okay, so it's actually just ends up being cos of 57 degrees. Okay, so how does 57 degrees relate to 33 degrees? Well, because it's also an acute angle, I'll be thinking in the direction of cofunctions. If I take 90 degrees, if I change this and say this is cos of 90 degrees minus what gives me 57? Okay, because I'm trying to change it into a cofunction. So 90 minus what gives me 57. I'm going to have to say 90 minus 57 to find out what I need to subtract by. And I find it's 33 degrees. So that means 90 minus 33 degrees is what gives me 57. You see, I didn't change the value of this. I just changed the way it looks because I'm using cofunctions here. Okay. Now, this cofunction is the one that speaks about cos of 90 degrees minus theta. And we know cos 90 degrees minus theta from cofunctions is just equal to positive sine theta. Okay, this is not the one that becomes negative. The one that becomes negative is cos 90 degrees plus theta. Okay, that becomes negative sine theta. Okay, so I'm going to use that. And it's equal to positive sine of 33 degrees. And what is sine 33 degrees? Well, didn't they tell us that in the beginning? It's m. You can also look for it here. Sine is opposite over hypotenuse. So opposite over hypotenuse is m over 1, which is just m. So we could have just looked at it from here. Sine 33 degrees is finally just equal to m. And that's our answer. Okay, so the next one we have 5.1.3 saying sine of negative 237. Remember, when your angle is negative, what do you need to do? Add 360 degrees to it. So if you add 360 degrees to this angle, let's see what it becomes. So negative 237 plus 360 degrees gives you 123. So this becomes sine 123 degrees. And now we can work with this. Sine 123 degrees is an obtuse angle. So there's two ways of doing this. When it's an obtuse angle, meaning it's less than 180 degrees, okay? But greater than 90, of course. You can either go through the cofunctions route, or you could just reduce this using your reduction and then try to simplify it. But for this one, I'm actually just going to use the cofunctions route. So I'm going to simplify this as sine of, and I'm going to break 123 degrees into 90 degrees plus whatever will help me to get 123 degrees again. So I'm just trying to find out if I have 120 degrees minus 90 is 33. So sine of 90 degrees plus 33 degrees is what gives me 123 degrees. Okay, this is using cofunctions. So you're breaking it up to 90 and another angle that when you add them together, they give you back that angle. Okay, so now that I have this, to use cofunctions in this is the same thing as having sine of 90 degrees plus theta. And this will become positive cos. Remember, it's a cofunction. It changes to cos theta. Okay, this is not the one that turns negative. Only cos 90 plus theta becomes negative sine theta. So this is going to just be cos of 33 degrees as our reference angle. You see, everything must relate to 33 degrees. That way we will be able to simplify it because we have a diagram. So what is cos of 33 degrees? I think we already found that. Cos of, no, we didn't. Okay, cos. Cos speaks about CAH, right? In SOHCAHTOA. So cos is adjacent over hypotenuse. So we're going to take the adjacent over the hypotenuse. Okay, so the side that is next to the angle is x, which is square root of 1 minus m squared over 1. So that is square root of 1 minus m squared over 1. But anything divided by 1 stays the same. So this just becomes the square root of 1 minus m squared. And that's cos. Okay, so that's our answer there. And we're really done with that part now. It seems like we're done with that diagram. 5.2 now says, given 4 tan of beta plus 5 is equal to 0, and beta is an element of 0 degrees to 180 degrees, determine with the aid of a diagram and without the use of a calculator the value of the square root of 41 cos of b. So we have another diagram. Okay, so they want us to find this with the aid of a diagram. We're first going to look at this. We have 4 tan beta plus 5 is equal to 0. We'll have to simplify this further. So I'll take 5 over. We have 4 tan of beta is equal to negative 5. Then to simplify, to find the value of tan beta, I'll divide both sides by 4. Okay. And so that means that tan of beta, let me just keep space, it's fine. Okay, divide by 4, divide by 4. So tan of beta is equal to negative 5 over 4. Okay, so this is what we have. Tan beta being equal to negative 5 over 4. What this is telling you is that tan is negative. Okay, tan is negative, tan of beta. So we need to think about it like within the diagram. where is tan going to have a negative value? Let me even draw the diagram in blue. So where is tan going to have a negative value? This is A, this is S, this is T, this is C, okay? The places where tan will have a negative value would be in sine's quadrant, because only sine is positive here, and in cos's quadrant, because only cos is positive here. Okay, so these are the two places that we have. But they also tell us that beta is an element of 0 degrees to 180 degrees. So from 0 degrees to 180 degrees, I'm going to mark all the quadrants that have this, they include these angles. And that would be the first quadrant and the second quadrant. Then you're just going to pick the quadrant with the most ticks, which is sine's quadrant. So that's where our terminal arm is going to fall under our radius. So I'm going to draw it there in sine's quadrant. Draw an arm and then extend it. Let it go down to the x-axis. It's perpendicular to the x-axis. And so our beta is this angle. That's beta. Okay, so remember the actual size of the angle is this obtuse angle, but because of the reduction, it reduces it to become an acute angle. That's why I'm measuring like that, because that's the actual size of beta. Okay, so what they want us to do is to simplify this, right, to find the value of that. But I have to actually complete this diagram. They told us the tan of beta is equal to -5/4. Okay, this is an interesting one. Because when you look at this, you know that tan is speaking about TOA in SOHCAHTOA, which is opposite over adjacent. Opposite over adjacent. Now there's a negative. So how do you decide which one the negative would belong to? You have to think about that carefully by looking at your diagram. Don't just give the negative to the 5. We don't know if it's 5 yet that takes the negative. You need to look at your diagram and see where's your opposite side. Your opposite side would be here. That's opposite beta. And that's the 5. So long I'm not putting down the negatives yet. I'm just putting down the values. Then we'll decide where the negative goes. Then the adjacent side, the angle that is adjacent that, okay, the side adjacent that angle would be this. And that is the 4. Now look at that carefully. Look at this as an x value and this as a y value. This y value is positive. That is positive 5 over there, right? So what takes the negative? It would be the x value. Do you see that this is the negative part of the x-axis? That's what takes the negative. So you cannot just assume the negative goes to the 5. You need to decide. Okay, so this is that one of the cases of tan. You have to decide there. So we only have to find the hypotenuse or the radius. Okay, so we can find that by saying, remember it's called a radius. So I'll say r squared is equal to, the hypotenuse squared would be equal to the one smaller side squared plus the adjacent side squared as well. So opposite squared plus adjacent squared. And then this is going to be equal to r squared is equal to, and we get 25 plus 16, okay, which is 41. So we have 41. And then if you square root both sides, you get r is equal to, now I would have said plus minus, but the thing about r is that a radius is a length. Lengths are always positive. They're never negative because lengths are really distance. Even if you walk backwards, it's not going to be negative. It's still a distance you've covered. So it's just the positive square root of 41. That is r. Now we have the value of r, positive square root 41. And the whole point of finding all of these is so that we can find the value of this 41 cos of beta. So let's go ahead and do that. The square root of 41. So square root of 41 cos of beta. So we have the square root of 41, which I'm just going to put there. And it needs to be multiplied by cos beta. So let's find cos beta. Cos is speaking about CAH in SOHCAHTOA. So adjacent over hypotenuse. So that is going to be, the adjacent side is -4. That's next to the angle. Okay, next to the reference angle over the hypotenuse, which is that. So what is -4 over the square root of 41? Well, because you're multiplying, these would cancel diagonally. This is on the numerator, this is on the denominator, they would cancel. And so you just be left with the -4 as your answer. Your answer here is -4. Okay, so there, that is our answer. And moving on to the next question. So that's for 4 marks. Okay, 5.3.1 says simplify the following expression to a single trigonometric ratio. Okay, so we're just going to simplify as we can. Okay, we have sine of 180 minus beta. Use your reduction. So I'm going to put down the reduction. Remember, you're going to have A, S, T, C, cost. Okay, and then we have here, because it's in terms of beta, well, I can say this is beta. Let me just leave it as normal. Theta 180 minus theta 180 plus theta and 360 minus theta. Okay, so we can reduce using that. So sine of 180 minus beta is the same as sine of 180 minus theta. That is sine's quadrant, so sine remains positive, so it will remain as sine, positive sine of beta. Okay, then multiply by, we have cos 90 degrees minus beta. This is a cofunction because you see 90 degrees. So cofunction, cos 90 minus beta is equal to positive sine beta. Okay, let me even list down the cofunctions here so that you remember them as well. Okay, so those are all your cofunctions. Okay, so that becomes sine beta. As you can see, cos 90 minus theta is sine theta, so this is sine beta. Then we still have minus 1 over, and we have cos of negative beta. See, that angle, look at negative beta. Beta represents an acute angle, but we have negative beta. So it means right now your angle is negative. What do you do when the angle is negative? You add 360 degrees to that angle. So what we actually have there now is cos, and now because we're adding 360, we have 360 degrees minus beta. Okay, and then we'll reduce that. So on the numerator, sine beta multiplied by sine beta, then we have minus 1, of course. Sine beta times sine beta is sine squared beta minus 1, and then over, this becomes cos beta when you reduce it, because this is cos quadrant, 360 minus theta, cos beta. Okay, so now we can simplify this. What does this become? Well, how do we simplify this in the first place? This looks a lot like an identity, a trig identity. Remember, your identities work like this. We have that sine squared of theta plus cos squared of theta is equal to 1. From this, we can create an identity for sine squared theta. It's like leaving sine squared of theta on this side, and then we still have on the right hand side the 1, and we're taking positive cos squared of theta over, and it becomes a negative cos squared of theta, right? So that is one identity for sine. Then we can also create one for cos. Cos squared of theta is actually equal to, we have the 1 on the right hand side, and we're taking over this sine squared to the right. So minus sine squared of theta. Now, if you look at this, which one does it look like it could become? Okay, you have sine squared of beta minus 1. That looks like it could become this one. The only problem here is, not really a problem, the only difference is here your 1 is negative, here your 1 is positive. And here your sine is positive and here your sine is negative. There's no problem with that. All you have to do here is to make it look like that one, take out a common factor of negative 1. So if I remove a common factor of negative 1 from that numerator, look at what I'll be left with. Okay, and I'm going to put it in this order. So let's look at what happens to this negative 1. Right? If you take out a common factor of negative 1, what do you have left? Negative 1 times what gives you negative 1? That's negative 1 times positive 1. You could have also said negative 1 divided by negative 1. It's positive 1. And we're going to do the same thing to the sine squared of beta. Sine squared of beta divided by negative 1 is negative sine squared of beta. Over, and then we have now cos of beta. Okay, so this is what we have so long. And now we know that this is the trig identity for this cos squared of theta. So I'm going to change that, and I'm going to say negative 1 is multiplied by this 1 minus sine squared of beta. I'm going to change it into cos squared of beta because now it's in the right order. You see that? It's in the exact order it's supposed to be. So that changes to negative 1, and we have cos squared of beta over cos beta. Okay, so negative 1 and then times this. Well, cos squared of beta divided by cos beta, one of the cos betas would cancel, and you just be left with negative 1 times cos beta, which just gives you negative cos beta, and that's our answer. Okay, so that was just the identity I was writing there. So our answer is negative cos of beta. Okay, moving on to the next question. 5.3.2 says, hence determine for which values of beta, where beta is an element of 0 degrees to 360 degrees, right? Where this will be undefined. Okay, so with this question, what I'm noticing is this is the exact same thing, okay, that we have here. But they want to find out within this interval, for which values of beta is this going to be undefined? Well, to make a number undefined or an expression undefined is, well, any number divided by 0 will be undefined. So if we can make the denominator to be 0, then this is going to be undefined. So I'm going to take what's on the denominator. I'm going to say this happens where cos of negative beta is equal to 0. And now I'm just going to solve for beta within this interval. Okay, so cos of negative beta, remember it's negative, so you just add a 360 degrees to it, which is cos of 360 degrees minus beta. And then if you simplify that, that is in cos quadrant, so it stays positive cos of beta is equal to 0. You have to solve for beta within this interval, okay, when cos of beta is equal to 0. Okay, so this is like general solution. It actually is general solution. So now that we have this, we're just going to say, first of all, I need to take cos over so that I can find what the reference angle is going to be. So I'm not going to say I'm solving for beta. I'm saying I'm solving for the reference angle specifically. I can call it reference angle. So, and this is going to be equal to, you're going to take cos and you're shifting, so taking it over, shift cos of 0. Okay, so what does that give you? So shift cos 0, it's 90 degrees. Okay, so we get 90 degrees. So I'm going to just solve now in this one. I will do the slow method, but it's not really necessary knowing what the cos graph looks like, and knowing that it looks like that. At 0 degrees, we have the cos graph, okay, has a y value of 1. But at 90 degrees, the cos graph has a y value of 0, okay? And I know that that answer is going to repeat itself again here, but let me just do it the manual way. It's okay. So I got my reference angle, and now I just need to solve for cos. So solve for beta, I mean. Just need to solve for beta. So I'm going to say beta is equal to, and we're going to look at the quadrants we're looking at. Because we have cos being equal to 0, cos is not negative, so we're just going to use the normal quadrants where cos is positive, which is going to be in the first and the last quadrant. You're going to use those reductions. In the first quadrant where everything is positive, the reduction we just have is theta. Okay, you just say the answer, whatever it is, the reference angle. And then in this cos's quadrant is 360 minus theta. Okay, so the first solution of beta is going to work like this. I'm just going to say that beta is equal to, and I'm going to say, since my first solution is just theta, meaning whatever your reference angle is, just put that down. I'm going to say my reference angle is 90 degrees. So I'll say 90 degrees, and then where this angle repeats, plus k of 360 degrees, because the cos graph is always going to repeat every 360 degrees. The sine graph also repeats every 360 degrees, and the tan graph repeats every 180 degrees. Okay, so from this, I'm already seeing that I actually just have to deal with it the normal way. Okay, so it's still going to make sense because we're looking at this function from 0 degrees all the way to 360 degrees. So we're literally going to take what the answers are within these intervals. Since our first solution was 90 degrees, okay, that's at that point, 90 degrees, that's where cos is equal to 0. We can see that cos is equal to 0 at another place here, okay, and this is how we're going to find that. So I'm not even going to say plus k of 360 because I can already see the solutions now. within this interval of 0 to 360 degrees. So beta is first equal to 90 degrees, or to find the second solution of beta, to find this solution of beta, I'm going to use the second solution of beta here where cos is positive. Okay, so I'm saying beta is equal to 360 degrees minus whatever my reference angle is, which is minus 90 degrees. And so 360 minus 90 gives you 270 degrees. Okay, 270 degrees. So beta is equal to 270 degrees. So these are your two solutions within that interval. These are the two places where the cos graph, cos of b, right, the natural cos graph would be equal to 0. Okay, so that's a graphical representation of that. Okay, so that's our answer. Beta is equal to 90 degrees or beta is equal to 270 degrees within those intervals. Okay, moving on to the next question. So the next question, 5.4.1 says, prove the following identity. Prove the following identity. So you have to prove that the left is equal to the right. There's more things to work on the left-hand side, so I'm going to use that. Left-hand side is equal to tan of alpha multiplied by sine of alpha plus cos of alpha. Okay, we have a tan. The minute you see tan in identities, you can change it so that it can simplify if it's possible for it to simplify with something. So tan becomes sine of alpha over cos of alpha. And this is being multiplied by sine of alpha. Then we have plus cos of alpha. Okay, so how can we simplify this? Well, look at the amount of terms that you have. This is the first term and this is the second term. So what I'm going to do here is I'm going to multiply here. This as a fraction, its denominator is actually 1. Okay, if it doesn't have a denominator, it's 1. Then we're going to have sine of alpha multiplied by sine of alpha, which would be sine squared of alpha, over cos of alpha times 1, which is cos alpha. Then we have plus cos of alpha, and I can already see how this is going to work out. So we're going to have to add these two together. But in order to add them, they're fractions. If you want to add or subtract fractions, the denominators have to be the same. So how do we get this one to have this denominator? Well, first of all, the denominator that is already on cos alpha, because there's nothing there, is 1. So how do you get this to have a cos alpha on the denominator? Well, why don't you just multiply the bottom and the top by cos alpha? That way, now you have a cos alpha on the denominator. Now you still have here sine squared of alpha over cos alpha. This is getting really small and cramped. But then cos alpha multiplied by cos alpha gives you cos squared alpha over cos alpha. Now that the denominators are the same, we can add these two together. So as a single fraction, it's now going to be sine squared of alpha plus cos squared of alpha all over the common denominator they have of cos alpha. The denominator stays the same. Now this is a trig identity. Sine squared of theta plus cos squared of theta is equal to 1. So sine squared alpha plus cos squared alpha is equal to 1. So this is 1 over cos of alpha. And that is equal to the right hand side. And there we go. So that identity is proven. Okay, moving on to the next question. We have a general solution. 5.4.2 says you need to determine the general solution of this. Okay, so the general solution of this, well, it looks a lot like the previous one that we have. So let's just see what's going on here. Because it looks a lot like the previous one, this helps us a lot. You see, do you see the left-hand side of this and the left-hand side of this? We managed to prove that this left-hand side was actually equal to 1 over cos of alpha, meaning I can replace this with 1 over cos of alpha. Okay, because I already proved that they're equal. I don't have to start with all of that anymore. So all of this is now 1 over cos of alpha. And that is equal to 3 over sine of alpha. Okay, and this is the general solution I need to solve for here. Okay, so I see sine and cos. I think it's going to be the one that will turn into tan, but let's see. Because I have a fraction and I have a fraction, I have an equal to sign, I'm going to cross multiply. So cos alpha multiplied by 3, that's going to give me 3 cos alpha, which is equal to the 1 multiplied by the sine alpha is sine alpha, Then this is going to become tan. So I see a cos alpha and a sine alpha. This is the big hint. One, I see cos and sine. And the second thing is that they're cos and sine of the same angle. So I can form tan because I know that tan of alpha should be sine alpha over cos alpha. So I need to form tan, meaning wherever I see the sine alpha, try to divide by cos alpha. And in order to do that, if I divide by cos alpha, what I do on this side, I have to do on that side as well. So in other words, I'm trying to get the cos alpha to come this side. I divide both sides by cos alpha, and this is what happens. Sine over cos alpha becomes tan of alpha, which is equal to 3. And I have to find the general solution of this now. Okay, so we're working with tan. And tan is also positive, as you can see. Tan is positive in which quadrant? Tan is positive in the first quadrant where all things are positive with a reduction of theta, and it's also positive in tan's quadrant where we have a reduction of 180 plus theta. So those are the solutions we're going to use for that. First of all, I'm going to find the reference angle by taking tan over. So that's going to become shift tan of 3. So I'm going to say shift tan 3. I get 71.56 degrees. 67, and I will round off here. The reason I will round off is because notice that by alpha, I don't have any coefficient. I don't have like a 2 or 3 or something that's gonna stop me from having to round off because I still have to like divide. I don't have to do that, so I can round off. It's 71.57 degrees, and I'll take it like that. So that's my reference angle. Now I need to use the solutions that I have here. The first place that tan is positive in is in the first quadrant, meaning when I'm solving for alpha, I can just say alpha is equal to whatever is in the first quadrant, which is theta. Theta is seen as our reference angle. Okay, that's our theta. So alpha is equal to, what's my reference angle? 71.57 degrees. But because it's a general solution, you have to make sure you answer them in general. Okay, the solution for tan of alpha equal to 3 is 71.57 degrees plus the amount of times that tan repeats itself, which is k of 180 degrees. You can say 180 degrees k, but I like to say k first so I don't forget the k. Okay, and then I'm going to say that, or then to get the second solution for alpha, I'll look at the second place where tan was positive, which is in this quadrant. So I'm saying alpha is equal to, and I have 180 plus theta, so that's 180 degrees plus the angle that I have here, which is 71.57 degrees. Okay, and so alpha is equal to whatever that's going to be. Honestly, I usually leave the answer like that because with the way the tan graph, that answer will just keep repeating itself every time. But I'm just trying to use the general way that it's worked out. Okay, so also please don't forget to say that k is an element of integers only, not real numbers, not natural numbers, but only integers. Okay, so what is that? Plus 180 degrees. Okay, it's going to give you 251.57 degrees rounded off to 2 decimals to 251.57 degrees. And again, this answer will repeat every 180 degrees because this is tan's function. The tan graph repeats every 180 degrees. So plus k of 180 degrees, and there we go. So, and we have k as an element of integers. We don't have to write it again. That would be the general solution of that. Okay, moving on to the next question, which now we are done with the expressions and equations in trigonometry for this paper. Okay, so with this question, do not be surprised if this is just a solution. Like I was showing you now with the tan graph, if you just got this one, that's really just the answer because the tan graph is just going to repeat every 180 degrees. And so this solution will just keep repeating every 180 degrees. It doesn't work like the sine and the cos graph. The sine and the cos graph, they curve, and that's the thing about them. If you have a cos graph, it does this. So if you were trying to find out where cos is equal to, for example, a half, you see, within the span of 360 degrees, you have two solutions for this. The tan graph does not behave like that. Tan graph, very different. Okay, the tan graph will be more like this. You have an asymptote and it goes like that. Okay, and that's 180 degrees, and then it continues. Again, you have an asymptote, and then it'll just keep doing that again every 180 degrees, right? So with the tan graph, if I just found where tan was equal to 3, it happens here. Guess what? It's going to happen 180 degrees later. And 180 degrees later. That's why if you left the answer like that, it will be fine for the tan graph, but not for the sine and the cos graph, because they curve. Okay, within the span of 360 degrees, the amount of degrees it takes for it to repeat, it can have two solutions. Okay, so moving on finally to trig graphs, question 6. Okay, so question 6 says, in the diagram, the graph of the function f of x is equal to cos x over 2 is drawn for the interval where x is an element of negative 180 degrees to 180 degrees. First of all, see the way they drew this thing? It looks confusing, but we'll talk about that soon. Okay, so you have, first of all, we have to find the amplitude of f. The amplitude is really just the height of the graph from the midline. And you find it easily by looking at the function like this. You see, if, for example, we have y is equal to just cos of x, even if it was x over 2, it doesn't really matter. You look at whatever number is in front of cos, the coefficient of cos. Because we don't have anything here, it actually means there's an invisible 1. Okay, now do not get confused. The amplitude here is actually 1. That's true. That is the height from the midline of the graph. It is 1. But something that you need to also think about is, what if it had negative cos x over 2? What would you say the amplitude is? If you said negative 1, that's not true. It's not negative 1. It's still 1. You have to take the absolute value of what is here, regardless of whether it's positive or negative. You take the value that is there. The reason why is amplitude is a height. Height cannot be negative. So the height of the graph is just the highest point it can go, measured from the midline of the graph, the middle of the graph, which will always be a height and will never be negative. As you can see, this graph, the highest it goes is to 1. Okay, so there, the amplitude of this graph is 1. Just remember, regardless of whether this is positive or negative, you just take the number that is there, not the negative of it, just the number itself, the absolute value. So the amplitude of f is just 1. It's the coefficient of the absolute value of the coefficient of cos. Okay, then the next question is the period of f. How do you determine the period? Well, you see, the period of the graph is going to be affected like this. If you have cos of something and then x, this is going to tamper with the period. It can either make the graph complete a cycle faster or make it complete a cycle slower. But to just find the period of the graph, this is how it works. To find the new period, you just need to say the old period of the graph divided by k, and k is whatever is your coefficient of x. Okay, so I'm looking at this and I'm like, what is the coefficient of x? Well, the way they wrote it, it just looks weird. You can rewrite this like this. Cos of, instead of saying x over 2, remember that the coefficient of x, the number in front of x, is actually an invisible 1. So you could have written this as 1 over 2 x. Okay? Because really that x is on the numerator because it was being multiplied by a half. And so x naturally has a denominator of 1. You said numerator times numerator to give you x. Denominator times denominator to give you 2. So we can separate it as 1 over 2x. So now we can see the value of k, the coefficient of x, is a half. So I'm going to just say u is equal to old minus k. So that is the old period, okay? That's what I'm referring to. New period is equal to old period over K. So what's the old period? Well, the old period depends on the type of graph you have. The original cos graph has a period of what? It has a period of 360 degrees because it takes 360 degrees for the cos graph to complete one cycle, meaning for the cos graph to repeat itself. If you go 360 degrees later, you're going to see the exact same shape. Maybe even draw it in another color. Same shape, okay? That's going to be at 720 degrees. If you keep going, you're going to see the same shape. That's how long it takes to repeat itself. That's the period, okay, to complete a cycle. That's how long it takes to complete a cycle. So the original period of a cos graph is 360 degrees, and I'm dividing by K, and I can see that K is a half. So K is a half divided by a half. If you say 360 divided by a half, you can use that on your calculator. It will give you 720 degrees. Okay, so there. It's going to take this graph 720 degrees for it to complete a cycle. It's completing a cycle at a slower rate now. Okay, next question. Okay, so 6.2, we have to draw the graph of g of x is equal to sine of x minus 30 degrees for the interval of negative 180 to 180 on the axes provided above. So we have to draw it above. Clearly indicates all intercepts with the axes and turning points. Okay, so we have to put those points down as well. See, with graphs like this, first of all, look at the fact that you have sine of x minus 30 degrees. So this is the normal sine of x graph, but you have minus 30 degrees. You are subtracting from the x. When this happens, okay, when we are working with the x or adding or subtracting to the x, it's actually a left or right movement. Okay, if it is up or down, then it will look like sine of x plus 1, for example, right? But this time we have an x, and then we have the minus 30. Now, this is another thing you need to remember. If it says minus an angle, it's actually moving to the right. If it says plus an angle, it's moving to the left. So it means that the normal sine graph is actually moving 30 degrees to the right. So how can we draw this graph? Well, if you know what the normal sine graph is going to look like, you'll be able to draw it. So already these are put in intervals of like 90s. So I'm going to say y is equal to sine of x minus 30 degrees. And you can really just plot it down. If you like, you could use your calculator and draw down to still work out. But I'm going to draw down according to how the sine graph usually works. The sine graph looks like this. Okay, that's a full cycle from 0 to 360 degrees. So when I'm drawing this, I'm going to draw it in intervals of 90 because usually we have 0 degrees, then we have 90 degrees. Okay, the sine graph has 0 and 0 at 0 degrees. Then at 90 degrees, it has a y value of 1. And then at 180 degrees, that's 90 degrees later, it has a y value of 0. Then at 270 degrees, it has a y value of negative 1. And then at 360, it has a y value of 0. That's how the sine graph would look. So I'm going to do that over here as well, throughout here. But the only thing now is the way the sine graph looks, what's going to happen is that it's going to be shifted 30 degrees to the right. So what it's going to look like is this. You see, at 0 degrees, we were supposed to have a y value of 0. But because this is saying x minus 30 degrees, meaning it's moving 30 degrees to the right, whatever answer was here is now going to move 30 degrees to the right. So now I have 30 degrees and 0 instead of 0 and 0. Then at 90 degrees, I was supposed to have 90 degrees and 1, right? So it's be 90 and 1. But because this graph is moving 30 degrees to the right, 90 degrees is not going to be 90 anymore. It's going to be at 120 degrees, and we will still have that same solution. So 120 degrees and 1. And then for 180 degrees, where we have a y value of 0, instead of 180 degrees, we're going to have it at 30 degrees to the right, which is outside our interval. So we can actually stop at this point here. We don't have to keep going. Okay, now if you're going backwards, how it's going to work, let me actually just take this and move it so you can see what happens if you move backwards. If you move backwards like this, and let's say I'm just going to negative 360 degrees. You see the shape is going to repeat itself here again. It's going to do that again. So at negative 360 degrees, you'll have a y value of 0. At 360 degrees later, okay, so 360 degrees moving to this direction, that's going to be negative 270 degrees. You're going to again have a y value of 1, okay, y value of 1. Even if on your calculator you actually do find sine of negative 270, right, you see that you get 1. And then 90 degrees later, we have negative 90, sorry, negative 180, right? And so if you check sine of negative 180, it's going to give you 0. And again, if you check negative 90 degrees, sine of negative 90 degrees, you're going to get negative 1 as your y value. Okay, so as long as you know what the normal graph would look like, you would know what the shift is going to look like as well. So I'm looking at it like this. I already dealt with a 0. So I'm looking at the fact that at negative 90 degrees, I have a y value of negative 1. But what should have happened at negative 90 degrees? It's supposed to be negative 90 degrees and negative 1, but my graph is moving 30 degrees to the right. So instead of it being at negative 90 degrees, it's going to happen 30 degrees to the right. It's now going to be here at negative 60 degrees. Then if we go to the next interval, 180, right? Negative 180 degrees. At negative 180 degrees, you should have a y value of 0. Okay, so at negative 180, we should have a y value of 0. But this graph is shifted 30 degrees to the right. So 30 degrees to the right would be at negative 150 degrees. That's where we're going to have a y value of 0 now. Okay, so that is our graph. You're just going to have to join it. So it's going to basically look like this. Okay, so this is what we have. Okay, so 6.3, we have write down the values of x in the interval. So that's the above interval for which f of x multiplied by g of x is going to be greater or equal to 0. So when they're saying f of x multiplied by g of x, please remember they're talking about the y values of f and the y values of g. What are the ways that we can multiply these two and they're going to give us something that is positive? Well, if f, the y values of f are positive, and you multiply it by the y values of g and they're also positive, then we will get a positive value. And also, if the y values of f are negative and the y values of g are also negative, then they're also going to give us a positive value. But remember that they can also be equal to 0. For example, if this is 0 and we times by g, which is positive, we're going to get something that is equal to 0 because they're also saying equal to 0 as well. So let's also just keep that in mind. So let me pin this to the screen and then we can see in the graphs where these happen. Okay, so this is what we have. We have the graph of g and the graph of f. And we're looking for where the graph of f and g are both positive, first of all. So this is where their y values are both positive. The places on, or the place on the y-axis where the y values will be positive is all through here. As you can see, that is above the x-axis. We will only be focusing, so to find this one, we'll only be focusing on values of the graphs that are above the x-axis. So they need to be above the x-axis at the same time, really. Okay, let's go ahead and start all the way from the left. Look at this here. So at negative 180 degrees, do you notice that g has a y value that is positive? And f has a y value that is equal to 0. So this is one that I can take because if I take f and I multiply it by g, I'm going to get 0, which is what I want as well. I want when we take f times g, it gives us 0 or value greater than 0. So negative 180 is a point that we're going to definitely take. And if we move to the right of negative 180, do you see that here the graph of g has a positive value and the graph of f also has a positive value. If you multiply those positive values, they give you a positive number. This is where they're both positive. And this keeps happening even here where they intersect, they're still both positive. It keeps happening, they're still both positive until 150. At 150, the graph of f is positive, as you can see here. And the graph of g at negative 150, right, is 0. But if you do take them, of course, if you say this positive value multiplied by the 0, the y value of 0, we will get 0. So it's one of the things we have to take. So I see that it's working here between negative 180 degrees and negative 150 degrees. It's happening there. Okay. Okay, so the first solution I'll put for that part, because I can see it's working all through here, right? I'm going to say this is where x is greater than or equal to negative 180 degrees, but less than or equal to negative 150 degrees. Okay, it works for that part. If we keep moving to the right, you see what happens here. G is negative, and at the same time, or for the same x value, you see that f is positive. So it's not working here. G is negative here. F is positive here. If you multiply their y values, it will not give you a positive value. It will give you a negative value. If we keep going, you see G is positive. F is positive and G is negative. That's not going to work. Okay, they need to be both positive. So if we keep moving, you see that at this point, G is now 0. Okay, so here where G is 0, if you take this and you multiply it by the y value of f, which is a positive number. It's not necessarily positive 1, but it's a positive number. It's going to give us 0. So 30 degrees is one of the things we can take as well, because when we take the y values of the two graphs, they give us 0, okay, which is what we want as well. Then if we keep moving to the right, you see that here, the y value of the graph of f is positive, and the y value of the graph of g for the same x value is also positive. And this keeps happening if we keep moving to the right. It happens here again, see, positive and positive. It happens here, positive, and it keeps happening throughout here. Still positive and positive until we reach this point at 180 degrees. The y value of g is positive, and the y value of f for that same x value is 0. If we multiply them, they will give us a 0. So we definitely can also take that value of 180 degrees. So I can say it's happening here as well in this region. It's happening where x is greater than or equal to 30 degrees, because at 30 degrees, when you multiply the y values, you get 0. But less than or equal to 180 degrees. Same reason, at 180 degrees, the y value of f is 0, and the y value of g is a positive number. If you multiply, you get 0. So these are our two solutions here. Okay, so I'm just going to write them down. It's where x is greater or equal to negative 1, but less than 150, or where x is greater than or equal to 30 degrees, but less than 180 degrees. Okay, so now we have to see, do we have situations where f and g are both negative for the same x value? Okay, because when we multiply them, they will give us a value greater than 0. Okay, so do we have a place where they are both negative? Well, that will definitely not happen. And here's the reason. You see that the graph of f is either always equal to 0 or positive. It's never negative. So we cannot find a place where f and g are, for the same x values, going to be negative. Okay, so that one won't even work out. It's only the first case that was seen. So it means that the solutions that we have is literally our answers, and that is our solution for that question. Okay, then 6.4 says, write down the values of x in the interval where x is an element of 0 degrees to 180 degrees, for which g of x is equal to f of x plus a half. Sometimes when they give you these type of equations, you have to tweak it a bit. You have to just work with it a little bit. Because if you see g of x is equal to f of x plus a half, it's like, what's actually going on here? Well, you can rewrite this as g of x. Instead, we can say g of x. And then we have is equal to, why don't we take the f of x over? So that it says minus f of x. And then this is equal to a half. Now, this is more understandable because we just need to look for values of x within this interval where if you take the graph of the y value of g of x and you subtract it by a y value of f of x, it's going to give you a half. But it must be within this interval. So I'm already going to look within this interval, 0 and 180. So from 0 degrees to 180 degrees only. That's what I'm going to look at. You're going to look at where you're going to take g of x and you're going to subtract it by f of x and it will give you a half. Now, look at what this is already implying. The fact that you have to say g of x minus f of x, it means that in this case, the graph of g, and as you can see, gave you a positive value. The only way this is possible that it can give you a positive value is if g of x has a greater value than f of x. So we're specifically looking for places where the graph of g is going to lie above the graph of f. Okay, the graph of f. So that's what we're going to be looking at within this interval. So if I'm looking at this, where is g above f? G is the blue graph, f is the black graph. So here, all through here, you see g is below f. But when we get to this point, now you see that g is above f. So we're looking for where we take the graph of g minus the graph of f, and it gives us a half. I'm already pointing at this because I can see here the y value, because it's f of x, right? G of x. These are y values. I've seen that I have a y value of 1, which is a nice y value to work with. It's a whole number. If I take the y value of 1, right, and for the same x value, and I take the y value of g, if I subtract it, it should give me a half. But I would need to find out what exactly is this y value over here on the graph of f. What exactly is that? Okay, so I'm taking the y value of g minus the y value of f. So what is this y value here? So we can find out if we subtract those y values, will they really give us a half? Then we'll know our answer. Okay, so this is the graph of f, and this is at 120 degrees. It's easy to find out the y value here. Here's the graph of f. It's cos of x over 2. So just substitute whatever the x value is at that point that you're looking for. It's 120 degrees, right? So what is cos of 120 degrees over 2? Yeah, put that on your calculator. If you say cos 120 over 2, that gives us a half. That's perfect. It gives us a half. So it means that the y value at 120 degrees on the graph of f is actually equal to a half. Now look at that. If you take the graph of g, right, g of x minus f of x, where does it give us a half? It happens here, because if you take 1 minus a half, you get a half. 1 minus a half is a half. So it happens at where x is equal to 120 degrees. That's where this happens. Okay, so that's our answer. This therefore happens where x is equal to 120 degrees. Okay, so let's just be sure that it doesn't happen anywhere else. So it was nicely seen here at 120 degrees. But we need to look for all the places where the graph of g is going to be above the graph of f. So it's still above the graph of f here throughout. So we found one answer here. And we keep going. So here it definitely cannot, that minus this cannot give you a half. They're too close. Okay, so I'm looking for something that has this kind of height. Okay, look at if we keep going. Now at this point at 120 degrees, what is the value of the graph of g? We can also find out that at 180 degrees, what is the value of g? So I can find out that by actually substituting 180 degrees into the graph of g. The graph of g of x was equal to sine of x minus 30 degrees. Okay, that was the graph they told us to draw initially. X minus 30 degrees, that graph. So if I substitute 180 degrees, I'll find out what exactly the y value is at this point. Okay, so if I substitute, and that is a half. Okay, so that is going to be a half there. It means that the y value here is a half. And if you look at the graph of f, look at the y value at this same 180 degrees, it's 0. So if you had a half minus the y value of 0, you still get a half. Okay, now many times actually this thing, you can look for it and actually find the values. What I would have done to stay safe, because I don't know if I drew the graph properly, is I would have actually looked at the normal sine graph and find out all the places that it could either be equal to a half, right? Because I needed to say specifically g of x minus f of x. So look for all the places that it could be equal to a half and where it could be equal to 1. because if it happens to be equal to 1, then possibly the graph of f would have a y value of a half. Then I could subtract like that. Okay, so I would look for it in more of a planned out way rather than searching for it. But with this one, the intervals weren't that far, so I could actually just look at it and search for it. So here we know that it actually does happen at 180 degrees as well. Okay, but with those ones, I've actually tried them. I know that they don't actually work. So it happens at 120 and 180 degrees. Okay, so at 120 and 180 degrees, so all x is equal to 180 degrees. And those are our two solutions within those intervals. Then the last question says the graph of h is obtained by reflecting the graph of g in the y-axis. Write down the equation of h. So they say you're creating this graph of h by taking the graph of g and reflecting it in the y-axis. What happens when you reflect a graph in the y-axis? If you reflect a graph through the y-axis, if a graph looked like this, for example, and you reflect it through the y-axis, it will look like this. Okay, so what happens is that look at the x values it used to have. It used to have negative x values, and then now its x values are positive. So what happens is that the x values will change. In other words, whatever the x values used to be, they're just going to get multiplied by -1. You see, they were negative here. If you multiply all these x values by -1, they will become positive, and that's why they are here. So reflecting in the y-axis causes the x values to change, and what I mean by change is the x values get multiplied by -1. Okay, so this is what I say about g. Instead of writing just g of x, I'm going to write what happened to g. The x values of g are going to get multiplied by -1. So x times -1, that's negative x. This is me saying the x values of g are going to become negative. And so this is a reflection in the y-axis. Okay, so h of x is equal to, and then g of -x. So now I'm going to rewrite my equation, and wherever I see x, I'm going to replace that with -x. So we have g of x is sine of x minus 30 degrees, right? So I'm just going to say that is -x minus 30 degrees. Okay, and sorry, I forgot the cos itself because, or the sine rather, it has sine. So the graph of g, remember, is sine of x minus 30 degrees. So this is now sine of -x minus 30 degrees. So I'm actually going to just leave it at this. So that's our answer. You can take out a common factor of -1 because it's sine, so it's fine to do that. So it's really just going to be h of x is equal to, take out a common factor of -1, so it's negative sine, and now this becomes a positive x and a positive 30 degrees. Okay, so that's another way. If you want to simplify this further, you can simplify it further like this. So instead of just taking out a common factor, the way it actually works is this, and I just want to include this so you can see what happens. I don't actually like to say just take out a common factor because in some cases it doesn't work. You would probably notice in my previous video in the paper 2 of Gauteng's 2022 paper, that one, if you just take out a common factor, sometimes it may not work out, especially with cofunctions. So with this, if you ever have sine -x minus 30 degrees, we're just going to use the rule that the angle here is negative, okay? Negative x, of course, stands for an acute angle, the x, of course. And the fact that it's negative, it means that this angle is negative. And then we're still minusing 30 degrees. So the solution is for you to add 360. So we'll just say sine, and then we're adding 360. So 360 degrees, and I'll just put the negative 30 next since it's a number, and then minus x. Then at this point, I'm looking at this and I'm saying, okay, to simplify this, what I'm going to do is write sine of 360 degrees. Then from these two terms, okay, the negative 30 and the negative x, I'm going to take out a common factor of -1. So I'm taking out the negative as a common factor. And then opening a bracket, then now I have 30 degrees plus x left. And then after that, what I'm going to do is I'm going to reduce this now. You see, this looks exactly as sine of 360 degrees minus theta. Just we're going to treat this 30 degrees plus x as if it's the theta. Okay, because we also have a minus there as well. Okay, so when you reduce this, it will become negative sine of theta. In the same way, this will become negative sine of whatever our theta was, which was 30 degrees plus x. So there we go. That would be how to simplify it manually, okay, without just taking out a common factor, because sometimes that doesn't work with co-functions. Okay, then we move on to question 7. Question 7, we have triangle ABC has AB, which is 11 units. So they're just given all the dimensions. And the question is for them, the question is to calculate the size of angle beta. The fact that they want you to find this, and they gave you all the sides, you have to use the cosine rule. Okay. The cosine rule says if you're looking for this angle, this is going to work like this. You're first of all going to say the side opposite it, right? That is AC. You're going to say AC squared is equal to, and then you're going to say the side next to it, which is AB squared, plus the other side next to it, BC squared. Then you're going to say minus 2 multiplied by AB multiplied by BC, okay, the sides next to it. Then you're going to say multiply by cos of that center angle, angle B. Now the difference between this one is you're just looking for this angle, angle B, cos of angle B. So you really just need to make this part the subject. Now I know there are situations where you can just simplify this further and make this the subject, but you don't always have to do that. In this one, we have all our values. So I would actually just substitute everything and then try to make that the subject. So AC is 15. So that's 15 squared, which is equal to AB squared, and AB is 11. So 11 squared plus BC, which is 6 squared, minus 2 multiplied by 11 times 6, then cos of angle B. Okay. Then I'm going to find out what these values are. Notice that on the right hand side, because there's more going on here, how many terms do you have? Well, there's a plus sign, here's a minus sign. So there's 1, 2, 3 terms. That is a term together. So what we can do is leave this together, and why don't we just add these two first? Okay, what's 11 squared plus 6 squared? That's what we should add first. And 11 squared is 121, 6 squared is 36. So 121 plus 36 is 157. So we have 157 here. And then what is 15 squared as well? 15 squared, I think is 225 here. So 225. And then we have minus, and now we can multiply these and then say cos of B. So I'm going to multiply those. What is 2 multiplied by 11? Multiplied by 6, of course it's going to be negative because there's a negative in front. Negative 132 cos of angle B. That's what we have, right? And now that we have this, all we can just do is, why don't we just make this the subject of the formula by leaving it alone on that side? Or we could also just realize that it is negative where it is. So to make it positive, we can take it over to the left hand side. So that now becomes positive 132 cos of angle B, which is equal to, now, what was already on the right hand side? We already had 157, so I'm going to rewrite that. Then what's coming over now? What was on the left hand side? That's coming over. So that is minus 225. Okay, so you just have 132 cos of, for the sake of space, I'm just going to subtract. What is 157 minus 225? It is negative 68. So this is negative 68. Then to get cos of angle B alone, I divide both sides by 132. So that answer divided by 132. Okay, and I get a fraction. So cos of angle B is just equal to negative 17 over 33. Then I just need to solve for angle B. So I'm saying angle B is equal to, and taking cos over, and that is shift cos of negative 17 over 33. Okay, so what is shift cos of that answer? If you like, you can actually put the actual number that you have there. So angle B is going to be equal to 121.01 degrees. Okay, rounded off to 2 decimal places because that rounds up and adds a 1 to the next decimal. Okay, so that is angle B. Okay, so moving on to the next question now. The next question is here, 7.2. I think this is the last, yes, it is the last question for trigonometry. So 7.2 says, in the diagram below, we have P, Q, R, and S are points in the same vertical plane. Okay, P, Q, R, and S, they're in the same vertical plane. And we have the angle of elevation of R from Q is alpha, so there's alpha. And the angle of elevation of Q from S is theta, so there's theta. And we have PS is equal to X units, there's X, and angle QRS is beta. Okay, the first thing they want us to do, really the only thing they want us to do, is to prove really that SR is equal to all of this. Like I always say, it doesn't matter what all of these are. You're just trying to find SR. But yes, you should be looking at these just to see if your answers are corresponding. So we want to find SR. I'm going to stop and say, where's SR? So SR is over here. And now looking at SR, I'm going to ask myself, what should I have in order to find SR? And you can use any formula. You can use the sine rule. You can use the cos rule. Well, I would recommend you don't use the cos rule because we don't see anything with squares here. So the sine rule would be good. Okay. You could also use trig functions. So where you have a right angle triangle, things like cos is adjacent over hypotenuse, things like that. Okay. So those are the things we can use. Let's think about what would help us find SR. Okay. When I look at SR, I'm thinking, how about I use the sine rule? Because in order to find SR, I would need to have the angle right opposite, the full angle right opposite. But this is not that bad because I have part of it, it's alpha. To get this other part, how do I get that? Well, as you can see, this is a vertical line. This is another vertical line. And we know it's vertical because QP is perpendicular to it. Since we have that, you see these two lines? They're going to be parallel. And they're already showing you those arrows that they are parallel. So, do you see a Z here? We have alternate angles, meaning angle Q1 is equal to theta. So if this is also theta, that means we actually have the angle opposite SR, which is great. Okay, now in order to use the sine rule, we should also have another pair that is complete. We should have a side that we can either find or that we have, and opposite that side, we should have an angle available. Now, I can't use QR. The reason why is because QR, first of all, I don't even know what QR is. I'm not sure if I can even find it. Maybe I can. But if you look opposite QR, the angle that I would use with it is this one. And you see that it's not even labeled. We don't know what it is. We could find it though, because of angles in a triangle. But it seems like more effort. What I would go with is this one. So I would use this line and I have to use the angle opposite it, using the sine rule, of course. And I would use that angle. Just remember the sine rule, right? In a triangle, if I have A, B, and C. In order to use the sine rule, maybe you're looking for this angle, for example, right? You need to have the side opposite it. That needs to be there. You need to have some value for it. And then you need to have at least one available angle and another available side. And that side needs to be right opposite the available angle. That's what I'm trying to do. Okay. It could also be the situation that you are looking for an actual side. So you need to have the angle opposite it available. And then you need to also have, for example, you can have a side that is already present, and then the angle opposite that side must also be present. So with this, all I have to do is I have to find QS because I already have beta. I have the angle there. I have to find QS in order to find SR really. So how do we find QS? You see, it's like Euclid. You want to find SR, but you see now in order to find SR, we first need to find QS. Well, QS is part of a right angle triangle, meaning you can use trig functions on it. So how do we find QS? Well, theta is our reference angle. QS is the hypotenuse. You just need to make sure that you have one side that actually is available, meaning one side that has an expression for it. The only side in this triangle that has an expression for it is PS. It's x. That's the expression given to PS. So by this, because theta is over here, and this is the adjacent side, and this is the hypotenuse, I have to use cos. So I'm going to say cos of, first of all, cos of theta is equal to the adjacent side, which is x, over the hypotenuse, which is QS. And this will help me to solve for QS. Okay, QS. In order to solve for QS, you can multiply both hand sides by QS. And so this means that QS cos of theta is equal to x. Then if you divide both sides by cos theta and cos theta, you find that QS, right, is equal to x over cos of theta. So there we have an expression for QS. It's x over cos of theta. Okay, and then I also have to mention that I found that angle Q1 is actually theta because of alternate angles. So I'm also going to say angle Q1 is equal to theta. Okay, now that that is done, all I have to do is now find SR. So I'm going to use the sine rule by saying SR over sine of angle Q, which is equal to, I need to take another completed side. I have QS now. So over Q is equal to QS over the angle right opposite it, which is sine of angle R. See? So this is the formula. This is what I'm actually doing. I'm going to just say SR, because I don't have SR, I'm looking for that, over sine of angle Q. Sine of, what is angle Q? Angle Q is this entire angle. It's made up of alpha and theta added together. So sine of alpha plus theta, and that explains that part, which is equal to, and then we have QS. What is the value of QS? It's x over cos theta. So that's x over cos of theta, and this has to be divided by sine of angle R. So sine of angle R, which is sine of beta. So to not confuse myself, I'll say x over cos of theta, but I'm going to use the division. I'm going to say divided by sine of angle R, which is beta, so sine of beta. And I just have to simplify this and try to make SR the subject of this formula. Okay, let's simplify this part first. So I still have SR over sine of alpha plus theta. I'm going to leave that like that. And then this, I have x over cos of theta. It's been divided. You see, this is a fraction. This is not a fraction. So make it a fraction by putting it over 1 first. When you're dividing by fractions, you're going to use the tip and times rule, which means that you're going to tip this first one. You're going to swap its numerator and its denominator. So it's now going to be 1 over the sine of beta, right? I tip it. Then I turn the division into a multiplication. That's the times part. So times. And I'm going to simplify this part. So SR over sine alpha plus theta stays the same. And then here, numerator times numerator, that's going to give you x. Denominator times denominator, that's going to give me cos theta sine beta. But I'm just going to see, okay, it's still in that order as well. We have cos theta sine beta. And now all we have to do is get this to go that side. Okay, and how we're going to do that is, because SR is being divided by this, to get rid of this, you would have to multiply both sides by this. So I'm going to multiply by sine alpha plus theta, and also on this side, sine alpha plus theta. And what happens here is they cancel, and you're left with SR is equal to, and x over this is being multiplied by this. It is on its own, so you can put it as a fraction by putting it over 1. So x times this is x sine of alpha plus theta over, and then we have this multiplied by 1. It will stay the same, so cos theta sine beta. And there we go. So let's just check if it is the same, and it is. Okay, and that is our answer. Okay, and that is the last question for trigonometry. The next question that we work on is more on measurement. Okay, so question 8, we have the diagram below shows an open rectangular box made out of steel metal. Its measurements are as follows. So we have a length of 27 centimeters, a breadth of 24 centimeters, and a height of 10 centimeters. So let's just label all of these so that we know what they are. First of all, the length is 27 centimeters. So this is our length that we have. And then the breadth is 24 centimeters. So that is our breadth that we have. And then the height is 10 centimeters. So that is our height. Okay. So the first question, 8.1, says that we need to calculate the total surface area of the sheet metal needed to manufacture this open box. Okay, so very big emphasis on the fact that this is an open box. So this top part, we will not need any material for that. Okay, let's go ahead and build up the formula that we're going to use for this. And the reason I'm saying build up a formula is because, do you see that this thing is for 3 marks? Okay, they will not give you a mark for calculating. The calculator does that. They will give you a mark for substitution and for your answer. If they just wanted you to substitute and put an answer, then it would be 2 marks. But the fact that it's 3 marks, it means that they want some sort of formula. Okay, so to get the total surface area, we're going to say, so we're going to start like this. Let's break up each of the shapes. First of all, let's start with the bottom shape. You see that? Because it's one of a kind. It's really the only one of its kind. We don't have a top that's going to cover this box. So that bottom is going to look like this. Since we have that bottom, it is some sort of rectangle. Well, it's longer than this. So something like this. And I'm just going to label it bottom, right? And it's only one of it. So remember, it has a breadth of 24 centimeters and its length is 27. So the length is 27. So that's that part, right? And so for that part, all we would say there is length multiplied by breadth, because I'm really just writing the formula out. So I'm just going to say L multiplied by B, right? For that, that's that part. So I'm done with that bottom part. Then I'm going to take these shapes here in the front and in the back. So that one looks something like this, right? And that shape, its breadth, it has a breadth of 24 centimeters. So that is the breadth, the B. And then it also has a height, okay? Which we're really going to use as a length, because you're looking at it as, this is a rectangle. I want to find the area of this rectangle. So I'm going to treat that as if it is a length, but I know it's called height. So I'm going to still call it height. So it has a height of 10 centimeters. Okay. So, but the thing about it is that how many of these shapes do we have in this box? We have this one and this one, and those two are exactly the same. You see a height of 10, also a height of 10. The height is the same. And then it has a length of 24, a breadth of 24, and a breadth of 24. So I'm going to just say that we have 2 of these, okay? And this is basically the front and the back of it. Okay, so to include that, what I'm going to do is, because it's total surface area, you're finding the area of each individual shape and you're adding it up together to get the total surface area. We got the area of that shape. So to get this one, I'm just going to say plus, then I'm going to put the area. So I remember that there's 2 of it. So I'm going to say 2 multiplied by, and what we have here in this shape is a height and a breadth. So multiply by the breadth times the height, right? And then the other shape that we have are the sides. So this side and this side, that's the left and the right. I'll just call them sides. So they look something like this, really. Okay, so first of all, this shape, it has a height of 10 centimeters. So that part is your height, which is 10 centimeters. And then it has a length of 27 centimeters. So that's the length, and it's 27 centimeters. So I'm going to add that and say plus, and I know that there are 2 of them. There's 2 of the sides that we have, that side and this side. So 2 and then brackets. I'm also treating this as if I am finding the area of it, but I'm going to name it according to what they are called. Okay, that's called the length, that's called the height. So it's 2 multiplied by the length times the height so that you can get the area of the shape. Okay, so this is our formula, and now we can just substitute and find our answer. So this is equal to the length times breadth that we were looking at of that first shape. That's the length, that's the breadth. So that's 27 multiplied by 24. Then we're saying plus 2, the breadth times height. And you see, it's really the same thing. Breadth everywhere is the same as 24. See, 24. So 24 multiplied by the height of 10. And then we're saying plus again, and the 2 multiplied by the length times height. And the length is 27 multiplied by the height of 10. Okay, so there we go. And now we can just go ahead and put this onto the calculator and see what we get. And our answer is 1,668. 1,668. And remember, these were in centimeters. But remember, we are finding the area of this. So it's going to be in centimeters squared. And there we go. That's our answer there. Okay, moving on to the next question. So the next question, 8.2, says 4.5 liter water is poured into this box. Okay, calculate the depth of the water in the box. Take note that 1 liter is equal to 1,000 centimeters squared. Okay, let's already take note of that conversion. We need to know, right, what the depth of the water is. And they're already telling us that 1 liter is equal to 1,000 centimeters cubed. So let's look at the visual of what's going on here. Let me just clear out all of these. Okay, so we're looking at this box, and what's actually going on is that we have water in this box, and it's specifically 4.5 liter water that is filled in this box. So 4.5 liter is filled inside. And they tell us that we have to calculate the depth of the water. I want you to notice what the depth is. How deep the water is would be measured like this. Kind of like picking up a rod or stick, and you're checking how deep is this water. In other words, you're really just trying to see what is the height of the water. Okay, technically that's what's going on. You're trying to find out what exactly is the height of this water. Not of the shape itself, but of the water. But for us to know what the height of the water is, we would have to know how much water is even in here. Well, they told us that there was 4.5 liters of water. But this is in liters, and that's why they gave us this conversion. So what is 4.5 liters of water in centimeters cubed? Okay, and just remember, centimeters cubed is the measurement for volume. So this is already speaking about volume here. Okay, let's convert 4.5 liters of water. 4.5 liters of water, since 1 liter, right, is equal to 1,000 centimeters. In order to get this into centimeters cubed, of course, we would multiply by 1,000. And this will give us 4,500 centimeters cubed. Okay, so that's how much water is in here. A volume of 4,500 centimeters cubed. But we're still trying to find out how deep it is. In other words, the height. The depth of it is speaking about the height of the water. Okay, well, since we know how much water is already in this container, and we also know that the length of this container is 27 and the breadth of it is 24, we can use that, because now we're going to kind of restrict the box to make sure that it only has a length of 27 and a breadth of 24. Then we can leave the height open. Okay, so we will not substitute anything for the height. So this is what I'm saying here. It's like we're going to calculate the volume, right? We're calculating the volume because we already have the volume of water in this container, right? I'm saying the volume is equal to volume of a rectangular prism or a rectangular container. It's always going to be the area of the base multiplied by your height. Okay, so that is 24 multiplied by 27. So 24 times 27, or let me rather say length times breadth, and then multiply by the height, whatever the height is. Now, the thing about this situation is that right now I already know the volume of this water is. The volume of the water is 4,500 centimeters cubed. So in place of volume, I'm going to say 4,500 centimeters cubed is equal to, and then now for the length of this container is 27 centimeters. So that's 27 multiplied by the breadth is 24 centimeters, 24, then multiplied by the height. I am not going to say times 10 centimeters because the water is not 10 centimeters high. We don't know how high it is. We don't know how deep it is. That's what we're trying to find out. So we're going to leave that open. So I'm going to still call that the height. And now this forms an equation where you have to solve for the height. Okay, now I'm not going to say centimeters cubed because I know that at the end of the day, because I'm finding the height, it's just one of the dimensions. It's going to be in centimeters. Okay, so I'm going to leave these as numbers. We need to solve for h. How do we solve for h? Well, we can get rid of the 27 and the 24. So if you like, you can simplify it further by saying 27 multiplied by 24. What is that? 27 times 24 is 648. So 648 times h, of course, is just going to be h. Then you have to solve for h by getting rid of this. You divide both sides by 648, and then it means that h is equal to, so just say 4,500 divided by 648. 4,500 divided by 648. I'm just going to say divided by answer because, okay, it might have tampered with the answer. So let me just use the normal number. Okay, so this is what we get, right? As a decimal, we get 6.94 rounded off to 2 decimal places. So it means that the height of this water, not the container, but the water is 6.94 centimeters. Okay, the height individually is in centimeters. That's why this was in centimeters cubed, because you were multiplying three things that were in centimeters. It's centimeter times centimeter times centimeter. That gave us centimeters cubed. Okay, so that is the height. In other words, that is the depth of the water. So you can just conclude the depth of the water is that centimeters. Okay, so that is it for measurement for this paper. And now we move on to question 9, which is on Euclidean geometry. And now we're on question 9, and question 9 says, okay, so they do give an instruction. They say give reasons for all statements in questions 9, 10, and 11. Okay, question 9 says 9.1, O is the center of the circle. A, B, C, and D are points on the circumference. Then we have AOB is a straight line, and we have AC and BC are drawn. OD is drawn parallel to BC, okay? That's parallel to BC, and intersects AC in E. Also intersects AC at E there. And then we have the radius of the circle is 10 centimeters and AC is 12 centimeters. We have to calculate the length of ED, and this is all for 6 marks. Okay, so there's going to be some steps that we have to take here. First of all, when you are given this load of information, you need to break it down. You need to put down everything they're speaking about first, okay? Before just looking at it and saying, how can I get the length of ED? Put down what you have so that your mind can already see, oh, okay, I have this and I have that. Now I'll be able to find this instead, okay? So one of the things that they mentioned that you have is, they said, first of all, the radius of the circle is 10 centimeters. Very interesting way of putting it. The radius of the circle. So now you need to know exactly what a radius is. A radius is a line that goes from the center of the circle to the circumference. So look at the radii that we have, the radii. So OA is a radius. That's 10 centimeters. OB is a radius. That's also 10 centimeters. In fact, OD is also a radius. That entire thing, okay, is 10 centimeters. Let me just write it here. So 10 centimeters, that whole thing, 10 centimeters. Okay, so now we know the radius is 10 centimeters. We've got that part. Then they say that AC is equal to 12 centimeters. AC. So from A to C, we need to look at it like that. That is 12 centimeters. Okay. And now they want us to calculate the length of ED. So let me already mention here, because I'm already seeing something. We can already see now, you see you have a triangle. You have one line being parallel to one side of the triangle, and you have that AO is equal to OB. In grade 10 and in grade 11, you would have learned something called the midpoint theorem. Okay, and this is what the midpoint theorem states. If you have a triangle and you have one side, okay, another line being drawn parallel to one of the sides of the triangle. Let's call this triangle ABC, and let's call that parallel line DE. Then, if they tell you that you have one side being equal to another side, okay, this is the midpoint theorem. This is what you have been given. You see, in every theorem, it is very important to focus on what have I been given and what do I have to prove. In this theorem, in the midpoint theorem, you will be given, first of all, that DE is parallel to BC. And what can you conclude from this? Well, what you can conclude from this, first of all, okay, so that's not the only thing given. You're given DE is parallel to BC, and you're given that AD is equal to DB, as you can see. What do we conclude from this? Well, we've been given two things. So you can already expect we're going to have to conclude two things. Well, for this theorem, that's how it will work. The first thing we will conclude is that AE is actually equal to EC. Okay. And then the second thing we will conclude is that you see this length of BC. It's going to be double the size of DE. Okay. So BC is actually twice the size of DE. Those are the two things you conclude. So I'm going to keep that on the side because it's probably going to help us, because I can see the scenario of the midpoint theorem over here. You have one side, okay, a line being parallel to one side of the triangle. You have these two lengths being equal. This is perfect. It's the midpoint theorem. So something that I always say is in Euclid, you don't just go find random things. I know I spotted the midpoint theorem, but I'm not just going to start simplifying it unless I see that I actually do need to. Here, this is what we're going to first do. Let's focus on the goal. The goal is to find ED. So now let's look at ED. How can we actually find ED? What are the things we should have in order to find ED? Well, don't we know what the radius is? We know the radius is 10 centimeters, right? So it means OD is 10 centimeters. If only we have OE, we'll be able to find ED. And that's where we start looking for things. So our goal right now is actually to find this length. If we can find that, then everything is fine. And now let's look at that. How can we actually find OE? Okay. So one way of finding OE is, let's look at the fact that I know that in the midpoint theorem, it does tell us that BC is twice the size of DE, right? So it would mean that OE, or rather BC, is going to be twice the size of OE. But that's not really helpful if we don't even know what BC is. So that's not very helpful. So why don't we look at this over here and see that we actually have a triangle, right? And in this triangle, do you notice that you have a line from the center of the circle going to another point over here, right? This point E. But what do you know about AE and EC? Because this is the midpoint theorem. You see, because we've already been given that these two lines are parallel and these two are equal, then wouldn't that mean that AE is actually equal to EC? And that's very helpful because you see we already know the full length of AC. So that would mean that these two lengths are also supposed to be equal, right? Using the midpoint theorem, of course. So this is actually the first step to getting to this answer, because now I found out that AE is actually equal to EC because of the midpoint theorem, like here, right? There's one of the conclusions that we have. We know that now. So I'm actually going to state that down because I can see this is what's going to lead to my answer. The first thing I'm stating down is that AE is actually equal to EC. And my reason is because of that midpoint theorem. Okay, now that I know that those two are equal, well, I know the length of AC. If these two are equal and AC is 12 centimeters, then it means that AE is equal to 6 centimeters. And remember, I'm focusing on AE because, well, I could have, because there's a triangle here. That's why. Okay. So now I know this is 6 centimeters. So this is 6 centimeters. And I have this as 10 centimeters. In order to find ED, remember, we have to find OE. So how can we find OE? Well, if this was a right angle triangle, we could easily use Pythagoras to find OE. So maybe it is a right angle triangle. Maybe we just can't see it yet. And that's because it actually is. You see, from the center of the circle to this, do you see that the line is being drawn from the center of the circle to the midpoint of this chord. The theorem, or the converse theorem of the first theorem, says if you have a line from the center of the circle to the midpoint of the chord, that line is actually perpendicular to the chord. So that's what I'm going to show them now. I'm going to tell them that OE is actually perpendicular to AC. And see, so OE is actually perpendicular to AC, and my reason for that is because of the line from the center of the circle to the midpoint of the chord is perpendicular to the chord. Okay, and there's the reason. So you may have some sort of shorthand way of writing it that your teacher has accepted. You can use that method as well. Okay, so now we know that these are perpendicular. The OE is actually perpendicular to AC. So I can put a perpendicular symbol there. And now this is actually a right angle triangle. And in this right angle triangle, we can finally find the length of OE. Okay, because we have AO and we have AE. So we're going to use Pythagoras. So OE is one of the shorter sides. So to find it, we're going to say OE squared is equal to, so one of the shorter sides squared is always going to be equal to the longer side squared minus the other shorter side squared. So that's going to be OA or AO squared minus AE squared. And the reason for that is Pythagoras. That's the theorem that we just used. So OE squared is equal to, what is AO? That's 10 centimeters. So 10 squared minus AE, which is 6 centimeters, so 6 squared. And we can just go ahead and find out what this is. I'll really just square root both sides and find out what that is. So OE is finally equal to, and we get 8. So OE is equal to 8 centimeters. Okay, we have OE. Now that we have OE, we'll be able to find out what exactly ED is. And this is how we're going to find out. Remember how we know that the radius of the circle is 10 centimeters, right? So if the radius is 10 centimeters and OD is technically a radius from the center to the circumference, then, and we also now know that OE is 8 centimeters, then what is ED? 2 centimeters, okay? So we can just show them that calculation. We can show them that ED, the length of ED is going to be equal to, and we will just say OD minus OE, which is of course 10 centimeters minus 8 centimeters. And so ED is finally equal to 2 centimeters. And there's no reason for this. This is subtraction or addition. That's not a theorem. That's just a fact. So there we go. And that's how we find the length of ED using all of those. You see, we had to use the midpoint theorem. We had to use the theorem about the line from the center of the circle perpendicular to the chord. Okay, so moving on to the next question. Okay, so the next question we have 9.2 says, in the diagram below, we have JG is a tangent to the circle FGH, so the circle at G. Then we have FG, GH, and FH are drawn, so those lines, those chords. And then we are told that JGF is equal to x minus 5 degrees and FGH is 3x. Okay, we have to calculate the value of x. Okay, so they're telling us about two lines being equal, which didn't seem to mention here really, okay? But they're telling us that FG is equal to GH. And this is for 5 marks. We need to find the value of x. Okay, so let's see what we can do with this. Well, this is not a diameter. We cannot use that rule that this is 90 degrees at all. But let's focus on the fact that they did tell us that this was a tangent, right? JG is a tangent. And what we can do with this is, since JG is a tangent, the angle between the tangent and the chord is always going to be equal to the angle that is being supported by that same chord. So it's this angle H. So it means that this angle here is equal to this angle here. This will also be x minus 5 degrees. So I'm going to note that down first. I'm first saying that angle H is going to be equal to this angle FGG. GJ. These G's are. Okay, FGJ. right? And the reason I'm saying it's equal is because of the tan chord theorem. I think your teachers would accept that tan chord theorem. Okay, so because of the tan chord theorem, and then we have, now that they are equal, I'm going to just therefore say that this means that angle H is actually equal to that x minus 5 degrees. Okay, so now that we have that, the fact that these two lines are equal is really going to help us a lot. You see, if you have a triangle and two lines in the triangle are equal, it means you have an isosceles triangle. Because two sides of the triangle are equal, you will notice that the angles that lie opposite those sides, so the angle opposite this is this angle, and the angle opposite this side is this angle. You will notice that those two angles would be equal as well. Okay, so in this situation, because these two sides are equal, it would mean that this angle, right, this one opposite that equal side would be equal to this angle. So I'm already going to state that. And the reason I'm doing that is because I can see now if I have everything in terms of x in this triangle, I can just use the interior angles of a triangle to find x. Okay, so I'm going to find angle F. Angle F is equal to, and I'm saying that it's also going to be equal to angle H. Okay, now the reason it's not isosceles triangle, it's actually because angles that lie opposite equal sides are equal. So you can say angles opposite equal sides are equal. Okay, so angles opposite equal sides are equal. And so this means that angle F is finally equal to x minus 5 degrees as well. So that's also x minus 5 degrees. And now we have a triangle. So if you sum up the angles in the triangle, it should give you 180 degrees. So that's what I'm going to do. I'm going to finally say that it means that if I take angle F, of course, I don't have to label the angles really. I'm just going to say if I take this angle, angle F, which is equal to x minus 5 degrees, plus this angle, angle G, which is equal to 3x, plus this angle, angle H, which is equal to x minus 5 degrees, that it should give me 180 degrees. And I'm going to say because of the sum of angles in a triangle, and you can also specify which triangle. And the name of that triangle is FGH. So sum of angles in triangle FGH. That's what I'm just going to say there. Okay, so now we can solve for x here. Okay, so we've got an x, we have plus an x, and also plus a 3x. So x plus 3x is 4x, plus x is 5x. Then our angles, we've got a negative 5 degrees, and then again minus 5 degrees, which is going to give you minus 10 degrees, which is equal to 180 degrees. But because this is a video, I'm just going to already take this over to get a bit more space. So if I take that over, it's just going to be plus 10 degrees. And so we have 5x is equal to 190 degrees. Then if we divide both sides of the equation by 5, what is 190 divided by 5? We get 38 degrees. So x is actually equal to 38 degrees. And there we go. Okay, so that was for 5 marks. And that is the end of question 9. Then we move on to question 10. Okay, so now we're on question 10, and question 10 says, in the diagram, RS is the diameter of the circle centered at O. And then they tell us that chord ST is produced to W. And then we have chord SP produced meets the tangent RW at V. And then lastly, they tell us that angle R1 is equal to 50 degrees. Okay, so the first question is we need to calculate the sizes of the following angles. Angle R2. So how do we find angle R2? Okay, let's go ahead and see what they have given us first of all. So we have a triangle here, and I see we also have a diameter basically. How do we find R2? And it's for 3 marks, so the steps are not that long. Okay, so based on where R2 is, okay? Because remember, you don't look at these things and then start guessing. We look at it and we're going to look at R2 and ask ourselves, where is R2? So first of all, I would think R2 is at the circumference, okay? So I could use rules about angles at the circumference. There is the rule about the angle at the center is twice the angle at the circumference supported by the same chord or arc. But the thing is that here we don't really have an angle at the center, technically, right? Being supported by the same chord. So that's out of the box. We're not going to look at that. But I could have also thought about angles at the circumference supported by the same chord or arc. But in that case, I don't know what P1 is. So that's not very helpful. Okay, so what else could I use? I could also use the fact that look at where angle R2 is. It is where the tangent is. Remember that RW is a tangent, right? We have that. And what do you know about the tangent and the radius OR at their point of contact? Well, the tangent is always perpendicular to the radius at the point of contact. So it means that this forms a 90-degree angle. That would mean that angle R1 plus angle R2 should give you 90 degrees. So that's what I'm going to start with. Angle R1 plus angle R2 should be equal to 90 degrees because of tangent perpendicular to radius. Okay, so it means that, well, I know what angle R1 is. So I'm just going to replace that with 50 degrees. It's 50 degrees. And so angle R2 is just going to be equal to whatever 90 degrees is minus 50 degrees. And that is going to be 40 degrees. Okay, so there, angle R2 is equal to 40 degrees. Okay, when you find something, it is best to fill it in because it may help you with the next question or with a future question. The next question is to find the size of angle W. Where's angle W? It's over here. Okay, how do we find the size of that angle? Well, the minute I looked at angle W, I was like, it's part of a huge triangle. That's what I thought of first. So that could be helpful, using it as part of a huge triangle. Because in this big triangle, we have in this triangle WRS, right? What we do have in this triangle is, first of all, we have that angle R there. Right, we have the size of that angle. And so the size of that is 90 degrees. If we just find the size of this, we'll be able to find angle W. But then I also thought, okay, you should also always look at the mark allocation to see if it's really long steps. But then I also thought of this. I felt like finding two angles at once might just take longer. So why don't I still try to use W as if it is part of a triangle, but not that big triangle. Look at the triangle I'm seeing here. W, R, T. Yeah, that triangle. Okay, W, R, T. But now in this triangle, and the reason I'm looking at this now, instead of trying to find this angle so that we can go ahead and find that angle, because you see in this we have W, we have R1 in this triangle, this blue triangle. And then we have this. This is still multiple angles. I don't want to go look for multiple angles. What I could do is use the exterior angle of a triangle. Look at this. This is an exterior angle. See, it's it's like an extension of one of the sides of the triangle. So this is the exterior angle. And we know that the exterior angle of a triangle is always going to be equal to the sum of the two opposite interior angles in a triangle. Okay, so it means this angle should be equal to this plus this. But the thing is, I don't have this angle. I want this angle, right? I have this angle and I also don't have this angle. So why don't we focus on finding this angle? Then we'll be able to find angle W since we already have angle R1. And this angle looks so much easier to find. Look at this. We have RS. That is a diameter. Since that is a diameter, the angle supported by a diameter in a circle is always equal to 90 degrees. So that is 90 degrees. I'm going to put that down first. I know now that angle T1 is equal to 90 degrees. And I can say the reason is because of angle in a semicircle. So angle T1 is equal to 90 degrees because of angle in a semicircle. And then now that I've put that down, I'm going to go ahead and use the exterior angle of a triangle. So I know that the exterior angle of the triangle, angle T1, which is 90 degrees, that is 90 degrees, should be equal to the sum of the two opposite interior angles of the triangle. The two opposite interior angles of this triangle is W and R1. So it's equal to angle W plus angle R1, but I know the size of that. That's 50 degrees. So plus 50 degrees. And so my reason here is the exterior angle of a triangle. Okay, so now I just have to solve for angle W, which is what they asked for. So angle W is finally equal to, you're going to take 90 degrees minus 50 degrees, because I'm taking the 50 over, and so angle W is equal to 40 degrees. Interesting. They're both 40 degrees. Okay, now that we have that down, always put it down, because it's going to help you probably with the next question or a future question. So that's 40 degrees as well. Okay, let's see the next question. Next question is asking us to find the size of angle P1. Angle P1. So angle P1 is here. Let me get rid of the other drawings. Okay, so angle P1. This is angle P1. They want us to find the size of angle P1. Well, I'm seeing a butterfly. So do you see that angle P1 is at the circumference, right, of the circle? But if we now draw these, if we find out the angle that at the circumference that is also supported by this chord TS, we find that that is angle R2. So it means that angle P1 and angle R2 are actually equal. So those two are equal. So I'm going to finally say that angle P1 is actually equal to angle R2. And my reason for that is because of, you can say angles at the circumference supported by the same chords are equal. Then you can also tell them, of course, the chord. Or you could have just said angles in the same segment are equal. That's another alternative reason for that same theorem. So angles in the same segment are equal. Okay, so this means that angle P1 is finally equal to 40 degrees as well, because angle R2 is also 40 degrees. So I'm going to put that down because that will probably help me in future. 40 degrees. Okay, moving on to the next question. The next question says that we have to prove that angle V1 is equal to angle PTS. Angle V1, let's look at that. Let me use a different color. Okay, so angle V1 is equal to angle PTS. Oh, you can already kind of. Okay, so PTS, that full angle. Okay, so let's see how that can actually work. Okay, so I'm just going to see how can they be equal to each other. Which one can I actually solve for first? That's what I'm going to be looking at. Okay, so now that I've drawn this triangle and I can see that in this triangle, do you see that angle T2 and angle S1 would be equal? But I also noticed that angle S1 has a lot to do with angle V1, because angle V1 in this part over here, right, in this triangle, angle V1 is an exterior angle. So it'd be equal to this plus this. Okay. Okay, but how do we now use that to actually find out why angle V1 is going to be equal to this angle over here? Okay, fine. How about we just write this angle, right? And write down exactly what it's equal to. So angle PTS. Let's actually write that down and see how we can also find angle V1. So they may not be the actual sizes of them, but they're going to be an expression for each of them. So if I look at angle, so I'm going to actually just attempt to find the angles, but I know it's not going to give me a numerical value. It's just going to be an expression. Okay, because looking at it any other way, it's really not working. I keep on meeting a dead end. So angle PTS is equal to, what is this angle equal to? Well, it's made up of angle T2 plus angle T1, which we already know the size of. It's 90 degrees. So angle T2 plus angle T1, and so angle PTS, the expression for this is angle T2 plus 90 degrees. Okay, that is an expression for that angle PTS. Let me also find an expression for angle V1. And the reason I'm okay with using, angle S1 is because I know that angle S1 is equal to angle T1. Sorry, angle T2, right? And we have angle T2 here. So what I'm going to do is I'm going to just make an expression for angle V1 as well. Angle V1 is equal to, so it's the exterior angle, so it will be equal to the sum of the opposite interior angles. So that is angle R, the whole of angle R. I'll just call it angle R because that is the entire R. I'm not speaking about R1 or R2, just the whole angle. Plus angle S1. Those are the two opposite interior angle of that triangle VRS. Okay, so angle S1. But the thing is that I know that angle S1 and angle T2 are equal because they're angles in the same segment. So you see how this works? Look at this. Those two angles are going to be equal. Okay, so because of that, I'm going to say, but I also know that, so I can say, but I also know that angle S1 is equal to angle T2 because of angles in the same segment. I have to remember all these reasons. I'm just trying to see how we can actually meet up. So in this equation, where I see angle S1, I'm going to replace it with angle T2. So I'll rewrite this equation again. So angle V1 is equal to angle R, which I know is 90 degrees. See, angle R is 90 degrees. 90 degrees plus angle S1 is angle T2. So now do you see that we have the exact same expression for those two angles? So because we have the exact same expression, that would conclude that PTS is therefore equal to angle V1. Okay, so now I just have to put this down and put their reasonings. So I said angle PTS was equal to angle T1 plus angle T2, right? Not because of any theorem, just because PTS is actually made up of T1 and T2. So there's no reason for that. And then I said that, and that was just a conclusion because I knew what T1 was. Then I said angle V1 was equal to angle R plus angle S1. So angle V1 was equal to angle R plus angle S1. And so that really just means that is because of the exterior angle of a triangle. So I'm going to put that reason. Okay, and I'm just specifying that triangle. And then I said, but angle S1 and angle T2 were equal. And that was because of angles in the same segment are equal. Angles in the same segment. And then this was just a conclusion. I was just rewriting this same equation here now, knowing that, knowing already that angle R is 90 and just knowing that S1 is equal to T2. So I replaced the S1 here with T2. And so because I saw they were equal to the exact same thing, 90 plus T2, T2 plus 90, it's the same thing. I said that they were equal. Okay, so that is 10.2. Okay, and then the last question, hence prove that WVPT is a cyclic quadrilateral. It's 1 mark, so this one is probably going to be simple. So WVPT. Okay, so that's WVPT. Why would this be a cyclic quadrilateral? Well, I can see that, you see this angle P1, we found that already. We found that to be 40 degrees. And can you see now that the opposite angle, the opposite interior angle is also 40 degrees? Okay, so it's a cyclic quadrilateral because the exterior angle of this quadrilateral is equal to the opposite interior angle. That's the reason it's a cyclic quad. So we can just go ahead and put that reason. Okay, but they did ask us to prove it. So I'm just going to state that angle angle W is 40 degrees and angle P1 is also 40 degrees. Okay, so therefore WVPT is a cyclic quadrilateral. Okay, and our reason is because the exterior angle of the quad is equal to the opposite interior angle. Okay, so there. And that is question 10, and that is a total of 13 marks. Okay, moving on to question 11. And question 11 says, 11.1, use the diagram to prove the theorem that states that angle P is equal to plus angle R is equal to 180 degrees. Okay, this is one of the circle theorem proofs that I actually do have on my channel. So remember, you have to practice your circle theorem proofs because a proof is definitely going to come in the exam. Okay, so we just have to prove that these angles will add up to 180 degrees. The minute that they tell you, you have to show that this plus this gives you 180. The lines that you're going to draw should not intersect the angles that we're talking about. So first we're going to draw a radius going from O to Q, and then another radius going from O to S. Okay, and then I'm going to call this angle O1 and angle O2, just so that it does not, bring any confusion. Then you need to also tell them what you construct. So I'm going to mention the construction. Okay, so construct OQ and OS. And now this is what we're going to do. In order to prove this theorem, we are going to use the angle at the center being twice the angle at the circumference to prove this theorem. So the angle O1 at the center of the circle would be twice the size of the angle P, because it's supported by the same arc, the minor arc, specifically QS. Okay, so I'm going to put that down first. So I'm saying that angle O1 is equal to 2 times the size of angle P, and because of the angle at the center being twice the angle at the circumference. Okay, I just said supported by minor arc QS because I just want to show that I'm speaking about that arc, because you see the both arcs are actually called QS. That's also QS, but that's the bigger arc, so it's the major arc. Okay, so that's the first thing we do, finding angle O1. Then we also have to look at, if you're looking at this diagram, look at angle O2 as well. Angle O2 is also a center angle, but which angle is it going to be twice the size of? Since angle O1, right, was equal to the angle supported by the same arc, because they were both supported by QS. So QS was supporting O1 and it was supporting angle P. Then O2 is going to work like this. Angle O2, you have to look at the arc that is supporting angle O2, and that would be QS as well, but it's the major arc QS. So since that is supporting angle O2, see, supporting angle O2, the angle at the circumference that will also be supported by this same major arc QS would be angle R. Okay, see, it's been supported by that major arc. So I'm going to say angle O2 is twice the size of angle R because it's supported by the same arc. Okay, and I'm specifying that it's the major arc QS. Okay, and then now with this, I want you to see O1 and O2. You see what they do? They are the angles that lie around a point. And the angles around a point always add up to 360 degrees. So it means that if I take angle O1 plus angle O2, it should give me 360 degrees because of angles around a point. So look at the equations for angle O1. We know that angle O1 is equal to 2 angle P. So that's 2 angle P plus angle O2, which is equal to 2 angle R. And so that's equal to 360 degrees. We just substituted. And then now do you see that there's a common factor of 2 all through? So why don't we just divide both sides of the equation by 2? And so we're going to have that. If you say 2 angle P divided by 2, it gives you angle P, plus 2 angle R divided by 2 gives you angle R. And this is equal to 360 divided by 2 is 180 degrees. And there we go. We have proved the theorem that angle P plus angle R is really going to give us 180 degrees. Okay, so moving on to the next question. I think this is the last question. Okay, this is the last set of questions for this paper. Okay, so 11.2, this is what we have. So it says 11.2, in the diagram, 2 circles are intersecting at B. So we have 2 circles intersecting at B and D. O is the center of the smaller circle. And then B, C, D, and E are points on the circumference of the circle O, okay, on the smaller circle. A is a point on the circumference of the bigger circle. A is a point there. And then they tell us that DEA is a straight line. And then we have OB, OD, OA, BA, BD, and BE are drawn. Then we have OA and BE. So these are all just lines. They could be because they're saying O, O, B, O. So these are radiuses that we have, or radii. And so OA and BE intersect at F, okay? And then they tell us that angle A1 is equal to X. So this is the one where we have an X. I'm going to highlight that X because we're really going to have to look at it. And the first question is 11.2.1. Name with reasons 3 other angles equal to X. Okay, so let's look at this. Now, something I noticed is that they didn't give any tangents, so we can't even use things about tangents unless they tell us there's a tangent. Okay, so what are the other angles that would be equal to x? First of all, I look at where x is, and I see that x is at the circumference. So I'm going to try and apply rules about the angle at the circumference. The first one I'm already thinking about, because I'm seeing a lot of lines crossing across, is the angles in the same segment. Okay, so let's just try to see. You see that x, right, that angle A1 is supported by OD, right, in this bigger circle. Let me actually highlight these two circles so that we can just be able to distinguish between both of them. Okay, so these are the two circles that we have. Now, do you see that OD is supporting this angle X, okay, which is angle A1 really, at the circumference. Now, let's look at, in this circle, in the blue circle, right, which other angle is being supported by OD? Well, if you extend, you see that we have angle B3 being supported by OD as well. So it means that this is equal to this. So that's another angle equal to x. So let's go ahead and state that down first. Angle A1, or rather angle B3, is equal to angle A1. Angle B3 equals angle A1, which is of course equal to x. And then I can just go ahead and tell them why it's equal, because of angles in this same segment are equal. Okay, so we got that one. And then we need to go ahead and see what else is this going to be equal to. Okay, it's equal to angle B3 in the smaller circle. Now, angle B3 is also at the circumference of the smaller circle, but I'm also noticing that I have OB, which is a radius, and I also have OD, which is a radius. Then do you see that there is a triangle OBD? It has a radius and a radius, so this is an isosceles triangle. Since we have the two sides being equal, it would mean that the angles that lie opposite these sides would be equal. So it means that this angle here would be equal to this angle here. Okay, because it's an isosceles triangle. Angles opposite equal sides. Okay, but with this one, I can't just say that those angles are equal. I have to tell them that we have radii there. So I'm going to tell them that OB is equal to OD because they are radii. So OB equals OD because they are radii. And now I can finally say that this therefore means that angle D2 is going to be equal to angle B3, which is of course equal to x. Okay, so that's what we have there. And a reason there is because we have angles opposite equal sides. Okay, so that's another one that's equal to x. I'm also just going to be by it. I'm going to put an x. Okay, so let's look at this. Angle B3, right? That would have, well, it's at the circumference, but unfortunately, do you see the sort of chord that is supporting it? Okay, the chord supporting it, if you looked at it as in the green circle, it would look as if it's not a chord actually supporting it, because always at the center, then you have D. But if you look in the bigger circle, technically it is a chord supporting it. Look at this. We have OD, right, supporting it. And so this angle is equal to that angle. But that means I can do the same thing for this angle D2. Angle D2 can now be equal to, let's just see, since in the bigger circle, the blue circle, right, we have this OB. This is a chord. It's supporting the angle. Let me actually just put this in the highlighter color. It'll be easier to get rid of. So this is a chord. Now look at this. Angle D2 is being supported by that chord OB. In this bigger circle, can you see any other angle that is also being supported by OB that also lies at the circumference? See, look at this. If I extend, that's OB. Angle A2 is also supported by OB, so it will also be equal to angle D2. So I can say angle A2 is equal to angle D2, which is equal to x because of angles in the same segment again. Okay, so there we go. So that is also equal to x. So I'm going to make sure that I do say that it is equal to x so I don't forget it. It's always good to write down whatever you have found. So that is also equal to x. Okay, so those are three other angles that are equal to x, and it is 4 marks. Moving on to the next question. The next question, 11.2.1, is calculate angle C in terms of x. Okay, angle C in terms of x. So we just need to find angle C. and it should be in terms of x. Okay, why don't we just use this triangle? Well, not the full triangle, but do you see that if you look at in the green circle, do you see BD? That chord is supporting the angle at the center, angle O1 and O2. Okay, so it means that this angle would be twice the size of the angle at the circumference because they're supported by the same chord. So why don't I just go ahead and find this angle, angle O1 plus angle O2? And I can do that because you see in this triangle OBD, this is a triangle and I have x here and I have x here. So I can find this angle in terms of x. Okay, so I'm going to just say angle O1 plus angle O2, right, as one angle, that it's going to be equal to, so angle O basically, it's going to be equal to 180 degrees minus angle B3, which is x, and minus angle D2, which is also x. Because I'm saying that if we add them up together, if you add this angle plus this angle plus this angle, you should get 180 degrees. Then I'm just making this the subject. Now, to be more accurate, I'm going to call that angle O, angle O1 plus angle O2. So this is because of the sum of the interior angles of a triangle. Okay, so there we go. And I specifically said sum of angles in triangle OBD, and you can say equals to 180 degrees. Okay, so in that triangle. Then I can simplify this further. So that's the angle O1 plus angle O2, which is of course angle O. And that is equal to 180 degrees minus negative x minus x is negative 2x. So I found that angle. Now that I have found this angle, I can use that to find the angle at the circumference because they're supported by the same chord or arc. So I'm saying the angle at the center, angle O1 plus angle O2, should be twice the size of the angle at the circumference, should be twice the size of angle C. Angle C, it's not C1 or anything, just angle C. Okay, so angle O, let me not skip spaces. Angle O1 plus angle O2 is equal to twice the size of angle C. And that's of course because the angle at the center is twice the angle at the circumference supported by the same chord or arc. Okay, and I just like to specify the arc. And then I'm saying angle C, that's what I need to find, right? So in place of angle O1 plus O2, I'm going to put this angle 180 degrees minus 2x because that's what it is equal to. It's equal to 2 angle C. Now I just need to solve for angle C. I can see there's a common factor of 2 and I just need to get rid of this 2. So we can divide both hand sides by 2. And so that would mean that angle C is equal to 180 divided by 2 is 90 degrees and negative 2x divided by 2 is negative x. And there we go. That's angle C. 90 degrees minus x. So I'll put that down. That is 90 degrees minus x. Okay, moving on to the next question. The next question, 11.2, says we need to prove that AE is equal to AB, is equal to AE. Okay, AB being equal to AE. So let me highlight those. That is AB and AE. The fact that you're trying to prove that two lines are equal. And do you see that in this, these two lines actually form a triangle, right? ABE is a triangle. If you want to prove that these two lines are equal, then one of the ways we can prove this is by proving that the angles that lie opposite these lines are also equal. Meaning, if you can show that angle B1 is actually equal to angle E2, then those two lines would also be equal because it would be a complete isosceles triangle. Okay, so that's one way. So let's actually see how this can work out. Okay, so really we have to focus on either finding angle B1 or finding angle E2. And that will help us to be able to find out whether they are equal or not. Okay, so if we can find one of those angles. Now, I'm looking at this and look at this. So I'm looking at this. I'm starting to see this. So let me just highlight it in a darker color. Let's use black. Do you see that in the green circle, we have B, C, D, E, right? This is a quadrilateral that we have here. And we have this over here, right? Which is an extension of DE. You see that we have an exterior angle here So the exterior angle of a cyclic quadrilateral is always equal to the opposite interior angle. So it means that angle E2 is actually equal to angle C. So I'm going to note that down first, because if I find this, it's really going to help a lot with even this little triangle. But I'll probably just use this bigger triangle to be easier like that. Okay, so let's go ahead and find that. So we're going to put that down. Angle E2 is equal to angle C. Okay, so angle E2 is equal to angle C. And we know now that angle C is 90 degrees minus x. And that's because of the exterior angle of a cyclic quadrilateral. Okay, so we know that. And now that we know that, this means that this is also 90 degrees minus x. Okay, so this is where we are now. We know that this is 90 degrees minus x. How can we use this to actually find out whether these two are equal? Well, if we can just focus on finding angle B1, and then if angle B1 happens to also be equal to 90 minus x, then it means that they are equal. So how can we find angle B1? Well, we can use this triangle here. This is a triangle. So angle B1 plus angle A, the whole of angle A, plus angle E2 should give us 180 degrees. Okay, so I'm writing that down. Remember, angle A is really just angle A1 plus angle A2. It was divided into two angles, right? And so this is because of the sum of interior angles of a triangle. Okay, so angle B1 is what we're looking for. I don't know what that is. I'm trying to find that. Angle B1 plus angle A1 plus angle A2. A1 and A2 are both equal to x. So x plus x. No, plus x, which we can just say plus 2x. And then plus angle E2. Angle E2 we already found now. I don't have to scroll up. It's already here. Angle E2 is now 90 degrees minus x. So plus 90 degrees minus x. And it's equal to 180 degrees. And now we just have to solve for angle B1. So we can make the x's go together. So angle B1 plus x is equal to 180 degrees. And then minus 90 degrees. I'm just taking that over. So that's 2x minus x is equal to a positive x. Okay, so that becomes a 90 degrees. And so angle B1 is equal to 90 degrees. And then just take the x over, minus x. So there, angle B1 is also equal to 90 degrees minus x. Then you can say, but we know that angle E2 is also equal to 90 degrees minus x. So that would conclude that angle B1 is equal to angle E2. And so because angle B1 is equal to angle E2, okay, because angle B1 and angle E2 are now equal to each other for real, then it would mean that this is an isosceles triangle. So the sides that would lie opposite these equal angles, so this side, AB, and the side that lies opposite this other equal angle, the side AE, would also be equal. Okay, so I'm going to state that AB is equal to AE. So therefore, AB is equal to AE. And my reason for that is because now I'm not going to say angles opposite equal sides are equal, because it wasn't the angles that we have proven that are equal. Well, it was, but then we're concluding that the sides are equal. So I'm just going to say sides opposite equal angles are equal. It's really the converse of that normal one. Okay, so sides opposite equal angles are equal. Okay, so there we go. And we have proven that AB truly is equal to AE. Okay, so now that we've proven that, just make sure to fill in anything that, needs filling in, because it could help you. So this is 90 degrees minus x. And I'm just going to erase those. I don't need those anymore. I know that these two lines are now equal. Okay, last question. Okay, the last question for this paper is 11.2.3, which says, prove that AB is not a tangent to the circle BCDE. We need to prove that this is not a tangent to the circle this. Okay, how do we prove that it's not a tangent? Okay, this is an interesting way of asking this, because the question is usually prove that something is a tangent. You have to think about it like that. If you want to prove that something is a tangent, you're going to use a theorem that has a tangent in it. And it's usually the tan-chord theorem. So if you want to prove that something is a tangent, then if you can prove that the angle that lies between the tangent and the chord is equal to the angle supported by that same chord, then this is a tangent, right? But now they said you need to prove that it's not a tangent. So why don't we just prove, if I call this A, B, C, why don't we just prove, and I'll call that B1, that angle B1 is really not equal to angle A? Okay, since we have to prove that it's not a tangent. Okay, so that is the plan here. Let's go ahead and see what exactly they were talking about. I'll pin this to the screen so we can focus on it. Okay, so they want you to prove that AB, where's AB? AB is here. So they want you to prove that AB is not a tangent to the circle BCDE. Is not a tangent to this circle. Okay. So let us focus on what angles should not be equal. These lines are too thick. I'm going to thin them out quickly. Okay, so let's look at this. In other words, if this is not a tangent, right, then the angle between the not a tangent and the chord, and this chord BE, right, that angle should not be equal to the angle opposite or the angle supported by that chord BE. So I'm kind of using the tan chord theorem, but I'm just saying these angles should not be equal because it's not a tangent. So it means that angle B1 should not be equal to the angle supported by BE at the circumference. That would be this angle. That's what we need to prove. We have to prove that angle B1 is truly not equal to angle D1. And if we can prove that, then it's not a tangent. So what do you think we should do here? We should probably just find angle D1. If we can find angle D1 and it's a completely different thing to angle B1, then they're not equal. Okay, so let's focus on finding angle D1. Okay, so I've looked for it trying to use this argument, right, of angle B1 not being equal to angle B2. It is an argument that will help to prove a tangent, but it's not the only one, because it's not the only theorem that we can use to show that something is a tangent, and so therefore to prove that something is not a tangent. You have to think about the theorems that speak about a tangent. So we know there's this one, the tan chord theorem, but there's also another theorem we also have to think about now. So this is why I'm letting go of this, because I'm seeing that I'm not really reaching a conclusion with this. So, well, I still need that there. But instead, what I'm going to use is this theorem. You know, if you have a circle and you have a tangent, right? If you happen to have a line drawn from the center of the circle to the tangent, it is always going to be perpendicular to the tangent at the point of contact. So if we are saying that we have this circle, this blue circle, CBD, right? That circle, and this is the thing that we're trying to prove is not a tangent. If it was a tangent, if we go to the center of this circle, O, right? And we go to the tangent, basically drawing a line that is going to the tangent, then we know that this line should actually be perpendicular to this tangent. It should be perpendicular. So if we can prove to them that this is truly perpendicular, then it would mean that it is. Okay, but of course they did say that you have to prove that it's not a tangent. So they're already concluding it's not a tangent at all. Okay, so let's just see. Let's look at the angles that are included here. Again, let me just make that thinner. Okay, so we're looking at it like this. We have OB and we have BA. We're going to have to basically prove that OB is not perpendicular to BA. I don't know if there is a word for not perpendicular, a symbol for it, but we have to prove that it's not perpendicular to BA. Okay, let's look at the angles that are here. Okay, so OBA, we're basically saying that OBA, we have to prove that this is actually not equal to 90 degrees. I'm not saying it's not equal to 90 yet. I'm just saying this is what we have to prove. Okay, let's see the angles that we have here. First of all, we have this angle B3 and then B2 and then B1. If you add all of them up together, they give you angle OBA. Let's actually see what they are equal to. So OBA is equal to angle B1 plus angle B2 plus angle B3. And let's actually just write them down. Angle B1 is 90 degrees minus x. Angle B2, We don't know what that is yet. And that's actually one that I could not find angle B2. Okay, but then we have plus angle B3, which is X, which we found already. Okay, so angle OBA, we have to show that it's actually not equal to 90 degrees. So OBA, let's just see what we get here when we simplify this. Well, we have a 90 degrees, and then we have a negative X and a positive X, which would cancel. And you have a plus angle B2. This actually shows you that it's definitely not equal to 90 degrees because angle OBA is equal to 90 degrees plus angle B2. Angle B2 has a size. So it means that this angle is already above 90 degrees. So here, this is our argument. And so because we can see now that OBA is an angle that is actually greater than 90 degrees, it would mean that it's therefore not equal to 90 degrees. Angle OBA cannot be equal to 90 degrees. And if angle OBA is not equal to 90 degrees, then it means that that line from the center of the circle, okay, to that tangent, that supposed tangent, is actually not perpendicular to that supposed tangent. So we now know that OB is actually not perpendicular to BA or AB. And so that would prove that it's really not a tangent because every tangent, okay, is always going to be perpendicular to the radius at the point of contact. Okay, so that's that one. I'll just put all of that down and yes. Okay, so it's not perpendicular to AB. Then I can therefore say that AB is not a tangent to the circle BCDE. And this is because our radius, or rather AB, is not perpendicular to the radius at the point of contact. Okay, so that is the last question for this paper. And if you've enjoyed this video, please leave a like. It really helps the algorithm, and subscribe for more content like this. And I will see you guys in the next videos.